all around the internet. It is bizarre. A report apparently prepared for Prime Minister Putin by Russia's Foreign Intelligence Service, circulating in the Kremlin, states that the German Chancellor, Angela Merkel, has now become the latest in a growing line of Western leaders to make a surprise visit to Afghanistan this month, following visits by President Barack Obama, British Prime Minister David Cameron, French President Nicolas Sarkozy. Only Sarkozy's trip was concealed, as he was already in India on a state visit when he was rushed, apparently, by U.S. military aircraft to the Afghan war zone. Why the sudden rush of these powerful leaders of the Western world to Afghanistan? This report continues. Directly view the discovery by the U.S. military scientists of what is described as a Vimana, entrapped in a time well that has already caused the disappearance of at least 8 American soldiers, trying to remove it from the cave that it has been hidden in for the past 5,000 years. A Vimana is an ancient flying machine. Sanskrit depicts it with different pictures. It's truly an amazing story. But could it be one of those internet myths? Well, up next, Stephen Quayle joins us. We'll talk with him about that on Coast to Coast AM. And welcome back to Coast. I'm George Norrie. A Vimana is a mythical flying machine described in the ancient mythology of India. References to these flying machines are very commonplace in ancient Indian texts, even describing their use in warfare, as well as being able to fly within Earth's atmosphere. Vimanas were also said to be able to travel into space and travel submerged underwater as well. There is a very strange story that is out there on the internet that talks about a Vimana being discovered in Afghanistan, in a cave, in a hole. I thought we'd bring Stephen Quayle in here. Michael Kremos talked about these cases before, too. Stephen, welcome back. How are you?
Good, George. Thank you. What a timely story this is to break, because the world's leaders are getting ready to make the grand announcement. The grand announcement will be that obviously we're not alone. We're being visited. But the Vimanas are even a more compelling story, because even going back to the time of Babylon and the Chaldean Empire, they stated, let me just give a statement, we'll go from there. The privilege of operating a flying machine is great. The knowledge of flight is among the most ancient of our inheritance, a gift from those from upon high. We received it from them as a means of saving many lives. Now, what's fascinating is whether you're reading it in Sanskrit, whether you're reading it in cuneiform, whether you're reading it in, talking about it, there are thousands of pages, not only on the fact that Vimanas exist, but how their propulsion system works, where they get their raw materials, and they describe in great detail, George, things that make the Pentagon absolutely salivate with the sheer glee of a new ancient weapon system. I was telling Tom Danheiser before we went on the air, I said, in order to understand the future, it's imperative to have a firm grasp of the past. And what's happening is all the world's leaders, all the world's ambassadors, they're all being, if you will, inoculated, and I'm using that word, into the knowledge that's been controlled by so few for so many years for the purpose of spinning it to enable them to complete their control over the planet. So Vimanas and the flying machines that the Babylonians, the Mesopotamians, and all others have written about, and the weapon systems associated with Gurkha talking about in the ancient Vedic texts, talking about the power of 10,000 suns, the vitrified cities, meaning cities turned to glass, radioactive skeletons. All this stuff is so old, and it all has a common theme that a if you will, supernatural group of beings, entities, came to Earth and gave this technology, and the privileged always flew around. Even Chinese emperors had flying ships in their ancient history. I'm talking 4,000 years ago.
This is a strange story, Stephen, in that it falls right on the heels of Secretary of State Hillary Clinton calling every ambassador back to D.C. for a very confidential meeting, which I've never heard of before. It's very strange.
Well, there are claims it's happened before. I can tell you this, based on what I understand, it has never happened before. The scuttlebutt behind all of the different people who are talking out of school, that are being threatened with their lives for talking out of school, is that they're being pretty much primed, if you will, and clued in, because they expect, U.S. government expects a mass backlash against the control of the information on flying saucers, aliens, ancient technology, and all that. So basically, you have to call the boys and girls home to give them a pep talk and a prep talk to prepare them to deal with the world leaders, because this is going to be a quantum shift in thinking. We're talking about an event now, and multiple events and multiple findings. And George, what they're admitting to is nothing compared to what they've had for 50, 60, 70 years. Stargates, as you know, the word time well is used in that article. And what you're also seeing behind the scenes, and the Coast family needs to hear this, and listeners, is that there is a war going on. The Chinese and the Russians and the U.S. and everybody else is vying for the ancient technology. So there's, if you will, a global hunt on for any form of the ancient technology. And there has been a group of people that, thank God, have been trying to keep the bad guys from getting this. But I'm telling you, we see on YouTube, we see actual spaceships firing laser beams at each other. We see masses moving into our solar system. We're seeing the effects on Saturn and Jupiter of, when I say electrifying, we're seeing electrical discharges on the planets and the gases. And so we're getting ready to behold some of the most amazing sights, and literally the Norway Spiral and all the things associated with CERN. CERN is a Stargate, and it's interesting that when you're dealing with CERN, the most sophisticated technology yet openly admitted to, and there's stuff that's way beyond that. But the point is, they use the god Shiva for their emblem, if you will. And the emblem of Shiva is, what Oppenheimer, one of the inventors of the atom bomb, said he had become the destroyer of worlds. So now we're reading about Vimanas, we're reading about ambassadors being called home. We're being told that all this stuff is going on behind the scenes, and it's right in front of us. And, there's a great word. It's called discernment.
That's right.
Discernment means to be able to tell, to see beyond, to go and probe the real reasons. And I think that the real story is yet to come. This is just the tip of the iceberg.
So this story that's all around the internet, which is bizarre, there's no question about it. It's bizarre that a Vimana is in a cave. It's been hidden for 5,000 years. Soldiers have merely disappeared trying to remove it. Can you believe that story?
Well, of course I do. Let me share this. And when it's not a question of belief, okay? It's a question of do we get anywhere near the truth of what really has been found? Obviously, the Philadelphia experiment. Have you ever had Al Bielek on your show?
Oh, many times. Many times.
Okay.
Boy, he's getting up there in age, too, now.
Right. And I mean, the people, and before Phil Schneider was murdered, okay, and talking about the deep underground military bases, bunkers, and stuff that he worked on, and the alien wars, everything. Again, the thing is that we've been so inculcated with basically lies and diversion, and I'd say perversion of the truth, that now that the ancient technology, the webbots are talking about secrets revealed. They're talking about the hidden technology. I think Cliff High uses the word space goat farts, things that are out of the realm of most people's comprehension. And this is one time, George, where everyone's going to have to basically get out of the box, the dumbed-down television, and start to read a little bit of history, just like what you were reading the background on the Vimanas. It's so astonishing that India has its brightest scientists recreating many of the actual compounds that are used. I mean, they're talking about graphite rods. They're talking about mercury. And what's fascinating, they're talking about cold fusion. That's why you're seeing platinum and palladium absolutely exploding in price. They're two of the rarest precious metals out there, but it's because they're used in this. So we're talking about red mercury. Remember years ago, you and I did a show on red mercury.
That's right. Now, though they don't disclose where this cave is in Afghanistan, I'm beginning to wonder if it's pretty darn close to the military man you had on our show years ago who found that giant.
Absolutely. By the way, it's ironic you would say that. I just received an email from him at 9:39 tonight. Okay?
That is strange.
And so I think your timing is just it's one of those time-based important points. The thing that's interesting is that when you find this type of technology, you also find giants. I broke the story from Iran, and I want to share this. The Iranians are basically not backing down. They're going to bring out some of the most astonishing skeletal finds. You know, the number one question I get on giants, and you cannot separate the technology from the giants. And as the Babylonian text says, that they were given the ability to fly in these machines from those who came from heaven, came to earth, or from heaven. In other words, the fallen angels, the gods of the Sumerians, as the Pentagon refers to them.
There is some inscriptions in this cave where this Vamana is supposed to be that claims that the rightful owner was a prophet called Zoroaster. He was Persian at the time. That's bizarre because he was real.
Well, and there's a whole religion, Zoroastrianism. I mean, for the record, Persia did not, embrace Islam until, not too long ago, maybe 1,000 years or so. But Zoroaster was very interesting because they worship the god Mithra, and it was Mithraism, Mithraism. And Zoroaster was basically a very, very knowledgeable guy. I believe he was most likely a hybrid, fallen angel, earth woman, because the knowledge that these guys possessed is like the priesthood. It's kind of like the Illuminati bloodlines. They absolutely claim divinity to the fallen angels and base their control of the information and the true artifacts of history and the true technology. It's just like Michael Cremo, Forbidden Archaeology. Not probably, if people would realize how much evidence, and Forbidden Archaeology is probably one of the best books in the world out there for detailing case. I believe Michael did a beautiful and brilliant job. David Childers, you've had Hatcher Childress on your show. He's written an amazing book on the ancient technology and the anti-gravitational propulsion systems of this stuff. And we can talk about the Temple of Saqqara, actually the Pyramid of Saqqara. And you can go in, and you've seen them, George. They have pictures of fighter planes. They have pictures of, they look like Star Wars speeders or speedsters, whatever they call those things. The thing is that the technology of the ancients so far surpassed what we're led to believe down what I call the primrose path of perdition and denial. And this is it. Who controls the true flow of information controls the population. And now we're seeing a return, in my opinion, to the very same political base that the Nazis had. And the Nazis sent out what were called the Ahnenerbe, and the Ahnenerbe went all through the world looking for religious artifacts, for the supernatural artifacts, and Hitler was obsessed with India and Tibet. And the scientists, the German scientists, even Dr. Werner von Braun, when he was alive, acknowledged the presence of aliens and star travel. The former head of Skunk Works said if the American people ever found out how that we've already been beyond the stars, that they'd basically string us up. Well, people don't get it, that guy just didn't get drunk at some going-away party. These are men who are in the deepest realms of the world of black physics and of, if you will, forbidden knowledge and forbidden to the public, but well known to them. So they're getting ready to spring something. The ambassadors of the world are being prepped. Everything is going to change dramatically, and this is a huge story. This has legs. Now, the source of that, the article you were reading was from a Russian disinformation service, but remember, even in disinformation, you can pick up nuggets of truth.
True, that's right.
And so the nuggets of truth, what you've got to do is put nuggets of truth into a historic context. And if anything, I want people to start to learn to do their homework. And if they'll do their homework, by the way, my new book, I told Tom, is coming out, God willing, May 1st, and it's going to be called something like, this isn't the final title, but it's Myths, Monsters, and the End-Time Technology.
Perfect. And we could be right in the middle of all of this, Stephen. Stay with us. We're going to take some phone calls with Stephen Quayle, whose website, stevequayle.com, is linked up right now at coasttocoastam.com. We're reacting to a bizarre internet story that says an ancient flying machine, Vamana. We've talked about them before in the program. Matter of fact, I was on the History Channel's Ancient Aliens talking about these things. I do believe that civilizations of the past had high technology anyway, but they say that it's been found in a cave, and we're trying to get it, but we just can't pull it out. That's weird. Anyway, we'll take your phone calls in a moment on Coast to Coast AM. I'm George Norrie. Well, next hour, physicist Brian Greene joins us as we talk about the hidden reality parallel universes. Really looking forward to that. When we come back, we're going to take your phone calls with Stephen Quayle about many of the things he covers, including this bizarre story of a Vimana being discovered in a cave in Afghanistan. Maybe, maybe not. Now, with a story like this, Stephen, will we ever get a real answer?
Will we ever get a real answer?
Yeah.
Absolutely, because I just got an email that kind of goes along with the same thing that you're asking that question, George. The guys are saying, do you think the government will ever really tell us the truth? Only when they're forced to, and it's no longer in our government's hands. I started out earlier in the interview saying that the Chinese and the Russians and the Iranians and the Egyptians, everybody is basically coming to the point of truth because they can no longer keep it hidden. A lot of the United States' foreign aid that went to Egypt, for instance, was to keep the real truth. You've had different people on your show that have talked. It's not what's on the Giza Plateau. It's what's under the Giza Plateau that counts. I've talked to special operations guys that have gone in and taken the giant sarcophaguses out of the underground citadel, their word, and you've had people on your show, especially that one lady, talking about the giants underneath the pyramids. You remember that story?
Sure do.
Well, the point is that the technology, by the way, the reason we really went into Iraq wasn't, the weapons of mass destruction. If you notice, the largest military base in the Middle East is being built in the very same area where Gilgamesh's tomb was, also where the cradle of civilization. It's not the cradle of civilization. It's, if you will, the landing port for a lot of the aliens. See, again, let me make this clear to people. The alien deception is going to be played out. They're going to attack the foundation of Christianity. They're going to attack the entire belief system of the world. And the guy known as the Antichrist, he's going to come on the scene after a horrific war, which, by the way, looks like it could be literally weeks away in the Middle East. They're going to have, if you will, the supernatural element. Then all of the secret and hidden technology and all the stuff they've known about will be utilized to basically wow and enslave those who are left alive. And it's so simple, yet it's playing out exactly to their benefit. So will the United States government finally fess up? They'll be forced to, because the Russians and Chinese are playing their hand right now. Iran, which does believe that the Mahdi will come out of the well, you've heard Ahmadinejad, but people don't understand that when they use the word time well or well in the context, they're talking about a Stargate. Obviously, when you understand the basis of Zoroastrianism and you understand what they thought, what they believed, you can't get away from the fact, George, that everything is happening, whether you're seeing triangular-shaped UFOs around the world, massive orbs, all of the different things that are coming out. Yeah, maybe 1,000 people can be hallucinating, 2,000, but now we're seeing tens of millions of people all over the world. You know, you watch the YouTube videos too, but the point is there are tens of millions of people seeing this. So when they can no longer contain something, then, like, they'll not let a good crisis go to waste. They will utilize this for their fear and control formula that has worked so well for so long.
All right, to the phones we go. Let's pick it up by going to Victoria, Virginia. Kevin is a first-time caller. Hey, Kevin, thanks for calling.
Yes, I agree with your the man talking there. I totally agree with him. I feel like ever since USSR went into Afghanistan, that we've been fighting over this thing that they've found here recently. Is they've just the seed that we just been found here recently. It's been known about for a while now. Been fighting over it, and I feel like I just want to ask you, the man on the show, a question.
Sure.
I want to feel like, is this the image? You think this could be the image of the beast? I'll take this off the air.
Okay.
Okay, I don't believe it's the image of the beast. I believe it's the technology of the beast, and utilizing the technology of the beast, they will obviously create, whether the image of the beast is a hologram, whether it is, there's so many different interpretations of it, but it certainly is the time period for the beast to appear. And some people believe that the beast is the computer system, all that. There will be a literal entity who will come on the scene as a world ruler. ruler step onto the stage when the whole world seemingly coming apart at the seams, and all he has to do, obviously, in my opinion, it's the devil, is just quit causing trouble. You got peace, you stir it up, you provide the solution, worship me, the devil speaking, and voila, we're into the 3.5 years of the Great Tribulation, and people are going to be absolutely forced by the control of food, natural resources, and the earth changes that are going to happen at such a tumultuous and perilous pace that they're going to be clamoring for any form of stability and something to eat.
Let's go to Noel in Ellensburg, Washington. There you go, Noel. Go ahead.
Hey, thanks for taking my call. I just wanted to say a few things about this. I'll try to spin them out quickly.
Sure.
You had mentioned a couple times videos on YouTube, which I think is ridiculous because there's absolutely no credibility on anything on that. Also, the ship they found in a cave somewhere. And don't get me wrong, I'm a true believer. I just think that some of this is over the top. I live in Ellensburg, which is where.
Can I answer the? Let me answer the caller. You think you're using words. You think. Sir, I would say this in the quest for intellectual honesty. Just because you think doesn't make something real or not real. Just because I tell you something's real or not real. The bottom line is the evidence is against you, and what you're doing is just volunteering your opinion, which you're entitled to, but your opinion has no historic standing, and not all the videos on YouTube are fake. Good night. There are people singing in rock bands that really existed, so your statement is just basically you're defeating your own purpose. There are legitimate sightings, there are legitimate videos, and again, if you're, and I got to tell you this, George, most people cannot comprehend this stuff because it destabilizes what they see as their world that gives them a peaceful place of understanding. So I disagree with the caller. He's obviously entitled to his opinion, but history is against him.
By the way, YouTube is so successful, we are going to debut in the not-too-distant future our own paranormal video network so people can share their stories like that in the genre, Stephen. You'll be part of that as well.
Well, I think that's incredibly wise. Again, the testimony of history. How many eyewitnesses? You know, first of all, anybody who would even understand the basis of evidence cannot make the statements that that gentleman made and be credible. Now, he's entitled to his opinion, but the point is that it's like this. It's like the powers that be have controlled the airwaves. They have controlled the publication realm. Outside of Coast to Coast and a few other shows on the radio and the people posting stuff on the internet, and look at how they're vilified. And when I know I've interviewed people, George, and so have you, that have been murdered after coming forth with what they know, I tell you this, they know something that got them killed, and so they don't get killed because they're just sitting around, you know, smoking hashish, okay? They get killed for what they've revealed because, again, the control of information is a control of the population. The dissemination of information is to direct the population to a desired point that the powers that be, the Illuminati, want them to be. And I believe that's the point of slaughter.
Let's go to our Skype line. Julio's with us, Ames, Iowa. Go ahead, Julio.
Hey, George, how you doing?
Okay.
God bless you, Steve, for all you're doing. Two questions for you. Number one, do you think, since we're living in like a genetically modified world with all of our food, our water being poisoned, weather modification, do you think with the secret meeting that they had in Afghanistan, they're getting things set for Project Bluebeam by NASA? And then secondly, national level exercise 2011 is coming up in May around Illinois and a couple other states. Do you think they will manipulate a huge earthquake like the new Madrid semiotic zone back in 1811 to get us into like a martial law scenario? And God bless you, Steve, once again.
Well, yes on all the questions, and take them one at a time. Project Bluebeam, or the holographic manifestation of whatever imagery that the powers that be want to project, is a very real technology. But they've even gone a step beyond that now with the voice of God through infrasonics and other technology being able to be beamed into our heads. a national level exercise. Everybody I talk to, everybody, it doesn't matter, intelligence, military, law enforcement, former whatevers, everybody is being told, get your 6 months worth of food, get ready, it's coming down. So their statement is never let a good crisis go to waste, and the best crisis is the one you generate to bring about the ultimate control over the people. So yes, 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 and more yes. Every day, what troubles me, George, is that the American people are vilified, whether you're a patriot, whether you're a veteran, whether you're a constitutionalist, whether you're somebody who believes in conspiracy theory. Good night. And I will say this, good bloody night. They're the ones who are creating the conspiracy and then claiming that people who identify the conspiracy are treasonous or are threats to society. And meanwhile, we take on, if you will, we're taking on the same outpicturing as the Third Reich or the Fourth Reich. And the point being is that control, control, control. And I started out on my radio career almost 19 years ago saying the ultimate goal of everything they do is ultimately control and destroy. And I think that's what we're seeing. The famine that's being generated, the floods. Literally, people should read the book of Isaiah, the 24th chapter. I posted it on my website, stevequayle.com, and read about how the earth is going to shake on its foundations, how it's literally going to split apart. And then we get into all of the prophecies of ancient land masses rising. The reason why India is having so many interesting finds archaeologically and historically is because a lot of the cyclones are turning up stuff that had been buried underwater. Good night. Grant Jeffries, not Grant Jeffries, forgive me, the guy that wrote Underworld. I'm trying to think of his name. One of the leading guys in the world wrote his book Underworld about all the ancient civilizations that have gone underwater, like Yanguni off in Okinawa and stuff. And so what we're at a point now where all that's coming to the forefront. The national level exercise that the caller talked about is under the guise of exercise, you preposition min and materials for an operational plan. And when we're hearing about $500 million in food being purchased, when we're hearing about body bags to be used in the case of flooding, when we're hearing about the crystal caves in Arkansas starting to resonate because there's so much energy being poured into them, that's called loading the faults, L-O-A-D-I-N-G, the faults. When you're talking about the very stuff of 6,000 years ago of the Vimana flying machines having beyond nuclear weapons, having weapons that would literally not only fry a person but cause them to disappear. And by the way, the Vimanas had cloaking, meaning invisibility. And so how do these ancients come up with formulas for propulsion? How is it that every civilization of the world that has the myths of either flying machines or craft of whatever kind, it's not just the Hindus, it's obviously the Babylonians, it's the Chaldeans, it's the Chinese. How does one explain that when you can get Chinese silk paintings of the emperor of its time flying around his little George Jetson machine? You know, it's astonishing because, again, that's the kind of history I pray we get taught. That's the kind of history that isn't being taught.
Stephen, you're very spiritual. There's a religious group out there that believes May 21st is going to be the end. What do you think?
I don't think that at all.
Neither do
I don't think that at all. I think that obviously the Illuminati, the Luciferian, the Brotherhood, they have dates that are significant to them. And what's interesting to me, George, is that the dates now are being thrown around ever so much. But everybody that I talk to, including the last time you and I were on your show together, some of the leading banking investment firms were headed into their bunkers already. So the strategic positioning of min and materials, and for those in the Pentagon, for those in the CIA, NSA, all of the 3- and 4-letter agencies out there, remember, there are people that you don't even know exist that are going to use you guys as cannon fodder. And when you go to where do we go next, it's going to be such a perilous period of time that there's never been anything like it. And this is what's going to be so destabilizing. Look at Australia. You just get over the floods and you get the fires. You just get over the fires, and now they got to deal with giant locusts. I thought that was – you probably saw that, George.
Yep, sure did.
Everything is absolutely becoming biblical plagues on steroids. And the thing that I think that is the most astonishing and yet confounding of all this thing is 2 and 2 still is 4. It doesn't matter if Time Magazine or Newsweek or CNN, Fox, if they say 2 and 2 is 7, 8, or 9. You saw the story. They're just now getting with the chemtrails. Excuse me? They're 15 years late.
Let's go to Greensboro, North Carolina, east of the Rockies. Hello, Ross. Take it away.
George, hi. Steve, tell me, do you think that we are now being influenced and monitored by ETs? And is Egypt, what's going on in the Middle East, is it proof of that? In other words, is there mind control being used? Because the Middle East has erupted overnight.
I don't think it's going to be an ET-related issue. Stephen, do you? I think
No. I share this. I don't believe so either. You've got to stir up the masses, and if you know anything about how the intelligence community works, and listen, I had some great instructors in this stuff. You are seeing absolute full-scale, full-court press of the destabilization of the Mubarak government. You're seeing it spreading into Jordan. Even the Queen of Jordan now is being targeted by Jordanian extremists. There's somebody stirring, I won't use the word, but stirring the stuff, okay? And the whole idea is to bring the whole world into a global upheaval. It's going to happen, by the way.
Yet it might be in some cases justified. Here's Mubarak. He's got $70 billion in the bank somewhere, Stephen. He hasn't worked a day in his life, really.
Well, no, and I got to tell you something. I'm not a fan of dictators, okay, including the ones that we have in this country. And in my opinion, okay, this is my opinion now, the people, remember the famous statement, it's not who casts their votes that count, it's who counts the votes that count. So
true.
The thing that what I'm trying to get people to understand is we're seeing, listen, the motto of the Illuminati is order out of chaos, ordo ad chaos. They have to take away the old to bring in the new. They're willing, just as the phoenix self-immolates, they're willing to nuke the different cities. By the way, I just posted a video on my website. Maybe you've seen it already, George, but a guy in San Diego saying, of course we've intercepted nuclear materials and nuclear weapons. Yeah. And now they're claiming he's crazy. I can tell you this. If it were not for the grace of God of some incredibly brave men and women in July of 4 or 5 years ago, 29 cities would have gone up in this country that had pre-positioned nuclear weapons. Yeah, you can't know that. Of course I can't unless somebody tells me that. But the point is that when I said that on your show.
Well, and Paul Williams also did. He believed 6 cities were targeted.
Right.
And he has come under the wrath of everybody because.
Oh yeah. See, so the thing is, remember this: you can't stand the song, so you've got to quit play. You got to kill the minstrel. You can't stand the message. You got to shoot the messenger. I mean, I got to tell you something. They work overtime to discredit anybody. When I talk about giants on your show, it's fascinating because Stan Deo, who handles my web statistics and website, he'll give me printouts, and I can tell you it's pretty amazing who listens to us. When we talk about that, it's like a hot button. We talk about Stargates, it's a hot button. We talk about the stuff that we talk about, it's like, some things they let ride, other things they won't let ride, and they interrupt. Today, for instance, Hawk, my guest host on my Survive to Thrive show,
right.
He was taken off the air the minute he went on, and the whole server farm.
I heard about that. Somebody clipped him, huh?
Yeah, they took him down. And the minute he got off the air, it all came back.
Nice timing, isn't it?
Yeah, nice timing. And what he was going to talk about, was the Middle East and the intel coming from the Middle East. Listen, this is a setup. This is an absolute manipulated setup to draw the whole Middle East into a global war. We'll get into it. The Russians are positioning assets. The Chinese are positioning assets. And this is a time for people to become sober and do their homework.
Well, you know the old saying, Stephen, times they are a-changing. Stephen Quayle, our guest this hour. Up next, physicist Brian Greene joins us. We're going to talk about some parallel universes. Brian Greene received his undergraduate degree from Harvard University, his doctorate from Oxford University. He joined the physics faculty at Cornell University in 1990 and was appointed to a full professorship in 1995. In 1996, Brian joined Columbia University, where he is professor of physics and mathematics. He is also the co-founder of the World Science Festival, pretty accomplished author. I talked to him years ago in my St. Louis show when he wrote The Elegant Universe, and here he is back on Coast to Coast. Brian, welcome. How are you?
I'm good, thank you. How are you?
Good to have you. Have you had a chance to see the Fox television show Fringe yet?
You know, I've been asked that a lot of times lately, and no, unfortunately, I have not seen it.
It's about a parallel universe. They have that. It exists next to ours. Their concept that there's more than one of everything. And you seem to have touched a lot on that with the hidden reality. Years ago, scientists never would have thought about that, would they?
Well, the idea that we may be one of many universes actually does have a pretty old history. It dates in early versions back to the 1950s, and I'm not talking science fiction here. I'm talking about a guy at Princeton University who was studying quantum physics who came to this startling conclusion. It's highly controversial, but his idea was that indeed we are one of many realities where different possible outcomes occur in these different universes.
Was he out there all by himself?
You know, at that time, he pretty much was. His name was Hugh Everett, and he was a student of a renowned physicist named John Wheeler. But it was such a new idea that there were very few people that would warm to it at the time. And in fact, the grand leaders of quantum physics, people like Niels Bohr in Copenhagen, when they caught wind of this idea, their reception was very icy. They had their own way of thinking about quantum physics that didn't involve other universes. So they pretty much clamped down on this idea, and only recently has it had a resurgence of interest.
Brian, let's talk about parallel universes and how you got to believe that they probably exist as well. What happened?
Well, I wouldn't go that far. I wouldn't say that they probably exist. What I would say is that many of our mathematical investigations into the deep laws of the cosmos have come upon the possibility that we are one of many universes. And because math in the past has proven itself a very powerful guide to the nature of reality, a powerful guide into realms that we can't yet see with experiment, we can't yet test through observations, we do take our math seriously. That doesn't mean the math is necessarily pointing to an aspect of reality. Only experiment and observation can establish that. But there are many pathways, and we can discuss some of them, which lead us to this possibility of many universes.
How did they form?
Well, it depends on which flavor. So one simple example is this. We've all heard of the Big Bang, which is the idea that our universe began in the distant past very small, and then underwent a rapid expansion, and it cooled down as it expanded, allowing stars and galaxies to form. Now, the little secret about the Big Bang that perhaps we don't emphasize enough when we talk about these ideas is the Big Bang actually does not tell us what happened at time zero itself. It does not, therefore, tell us what actually banged, what actually caused the outward swelling. Now, we have been working diligently for decades to try to fill in this gap. And we do have an approach. It's called inflationary cosmology. The reason I bring it up is when we study this new approach, it seems to indicate that the Big Bang may not have been a one-time event. It may not have been a unique event. There may have been many Big Bangs. There may continue to be many Big Bangs, giving rise, each and every one, to an expanding realm, which would be a universe. Our universe then would be one of many. The image that I like to have in mind is as if you have a grand cosmic bubble bath, with our universe being one expanding bubble, and there are other bubbles out there, other expanding universes.
What, prior to a Big Bang, what might have happened before that? What was around before that?
It's a very tricky question. You know, in the most conventional approach to that question, one would say there may not have been a before the Big Bang. The Big Bang may have been the beginning of everything, and asking what happened before the Big Bang is like asking how do you go further north than the North Pole, a meaningless question. However, in this multiverse scenario, it is actually meaningful because the Big Bang may not have been the start of it all. It may have been the start of our part of it all, our universe. Mm-hmm. And if that's the case, then the answer to your question is there were other Big Bangs before ours, giving rise to other realms.
And there probably will be many more.
If this approach is correct, then there would not only be many more, there would actually be infinitely many more. It's a process that would never end. The grandest landscape, the bird's eye view of the whole shebang, would have many, many universes, creating universe upon universe as Big Bang upon Big Bang creates these expanding realms.
Would these parallel universes, Brian, all look the same?
Not necessarily. When we study the math behind these ideas, we find that the detailed physics, the detailed features of these other realms could be pretty different from ours. The kinds of particles that are there could be different. The kinds of forces in operation could be different. So our universe would be one flavor of universe in a spectrum of other flavors that would have other physical features.
Could we technically exist in a parallel universe while we exist in this one?
That's a great question. So I would say we can't literally exist in two. I mean, we certainly exist in one. But the other universes, some of them could be quite similar to ours. And in fact, the math indicates that not only could some be quite similar, some would be so similar that there would be a Milky Way galaxy, there would be a sun, there would be an Earth, and there would be people walking around on that Earth that would look just like you and I. There would be literally copies of us, potentially, in those other realms.
I have sometimes wondered if deja vu was exactly that, Brian, where these parallel universes somehow get out of kilter by a little bit, and events that we say, hey, I've done this before. I know we really have, but in another universe.
Well, it's natural to have that suspicion, and it's very natural when you hear these fairly far-out ideas to try to connect them to those kinds of experiences that don't perhaps have an obvious explanation right here. My own feeling is that most of those attempts actually are not pinpointing something that is actually true. And my own feeling with the things that you're describing is we tend to take notice of coincidences. We tend not to notice when coincidences aren't something that really captures our attention. You know, the phone rings and you're just thinking about the person on the other end of the line, and you somehow want to ascribe some sort of causality to your thinking about them and then the phone ringing with them being there. But how many times does the phone ring and it's not the person that you were thinking of, and you don't take notice of it in that case? So my own feeling is that these other universes, however spectacular the ideas may be, are not the answer to some of these little mysteries that we encounter in our daily lives.
Brian, has science come up with the why factor yet? Why
No.
all this is?
I would say no. That's really where science is pretty silent. If by why you mean why with a capital W, why are we here? Why is there a universe? That kind of why?
Yeah, that kind of why.
No, science is not good at that kind of a question. Science is very good at the how questions. If you ask me, how did the universe come to be? How do the laws of physics operate? How do particles coalesce and yield stars and planets? Science is pretty good at those kinds of questions. But if you ask why, from the standpoint of meaning and purpose, science is silent.
And if I said, how did they start? How did these particles come about? That would be difficult, too, I would guess.
Very difficult. So what we continue to do year by year, decade by decade, is push our understanding ever more deep and ever further back in time to get a clearer understanding of how things got started. But no matter what science comes up with, you can pretty much say, what happened before that? Or why those laws? Or why that explanation? And those kinds of questions are valid, and they're certainly ones that science cannot, as yet, always address.
Let's talk in terms of time, the way we know time to be. These parallel universes, could the first one, assuming there was one and then it became 2 and 3, could the first one be trillions and trillions of years old?
Sure. In fact, it really depends on the exact flavor of multiverse. I mean, perhaps we're saying that, in my book, The Hidden Reality, I cover 9 different versions of how our universe might be one of many universes. And the simplest one was the one that we just discussed with the multiple Big Bangs. And in that scenario, a given universe that arose from a Big Bang could last for trillions of years. So that's absolutely possible. In other flavors of the multiverse, the universes would perhaps all have the same age and be the same age as the one that we are familiar with, which is about 13.7 billion years old. So the detailed features of these different universes really does depend on the kind of multiverse that your investigation leads you to consider.
What I find so fascinating about all this is when you think we're here for, let's say, 80 years, which is a pretty good run, we're talking about the cosmos that is so old, it defies our imagination.
Oh, it does. In fact, Carl Sagan had a great way of trying to envision it. He said, look, if you take the history of our universe and imagine that it took place in one calendar year, compress it to one calendar year, then humans would actually only come on the scene something like 10 minutes to midnight on December 31st. and all of recorded history would roughly be in the last 30 seconds or something of that sort. So that gives you a sense of how little on the grand cosmic scale our presence on Earth has been.
And on the probability scale, what do you say the odds would be that we live or we have parallel universes?
It's a natural question to ask. And it's a very hard one to answer because
sure.
If I was to throw out a probability, it would just be kind of from the seat of the pants kind of approach. What I find compelling is, and this is actually the theme that runs through the book, The Hidden Reality, is if you trust mathematics, and there's reason to do that. Look, in 1915, Einstein published his general theory of relativity, math that describes gravity. It predicted that the universe should be expanding. Einstein himself did not believe the math. 12 years later, observations of distant galaxies showed that the math was right. His math also established that there should be black holes. Einstein himself did not believe it. Observations now show that there are black holes. Math can be a really potent guide to the nature of reality. We are now following in Einstein's footsteps. We are following our math and seeing where it leads, and at least people like me are willing to take some of the conclusions seriously enough to investigate further. And time again, the math is pointing to at least the possibility of there being other universes. I can't really assign a probability to it, but to me that's a very compelling picture, and it's what drives me and many other physicists to pursue these ideas with great vigor.
Can we conclude that the math doesn't lie? And by that I mean it's, you use that formula, it's going to be the same no matter what.
That's correct. But the one thing that you need to bear in mind is just because something is implied by a mathematical equation doesn't necessarily mean that it's real. I mean, if you were going to a math library in some university and pull a random math book off the shelf, you'd find all sorts of equations that people have dreamed up during their mathematical research. It doesn't mean that each and every equation is necessarily describing something that's real in the universe around us. It may just be an interesting collection of ideas that mathematicians thought of. We, as physicists, need to find which mathematical ideas are realized in the universe, and that's what our charge is. Whether or not these equations that suggest there are other universes, are they real? Are they actually describing the nature of reality? Or are they kind of figments of a mathematical imagination?
These theories that are out there, has anybody come up with the God theory in science yet?
It's a very natural question to ask because when you're talking about things like the origin of the universe or origin of universes, you are brushing up against the kinds of questions that many of the world's religions do weigh in on, do have their own perspective on how the universe was created. Within physics, within science, there is no place, at least in the math and the ideas that I've ever studied, that God is inserted or finds a natural home or is called out for in our analysis. That doesn't mean that there isn't a God. It just means that for the day-to-day work that people like I do, we don't need to rely upon a divine being. We rely on the math to make predictions that we then go out and test to see whether or not they are confirmed. Now, you could always say, well, God is behind the math. God is what set the universe in motion in the first place. You can't really rule out that kind of idea, but it's not called for in the analysis that we undertake.
Might these parallel universes have all started simultaneously?
Some of them would. So, for instance, in one of the chapters in my book, I think it's chapter 8 that is, I discuss a multiverse that we began with in our conversation here that comes from quantum physics. And it's perhaps worth noting what that multiverse says. So quantum theory is an approach to describing reality which says that the best you can ever do in any situation is predict the probability of one outcome or another. say there's a 50% chance that a particle might be here and a 50% chance that it's over there, and that's the best you can do according to the laws of quantum physics. Now, that sets up a strange situation because whenever we measure a particle, whenever you look around the room that you're now in, everything appears to be in a single definite location. The puzzle is, how do you go from the probabilities of the quantum mathematics to the definite reality that each and every one of us always experiences? We have yet to be able to bridge that gap. What Hugh Everett said in 1957, he said, look, here's how you bridge it. If there are two possible outcomes in a given quantum experiment, then each actually happens, but each happens in its own separate universe. If the particle could be here or there, in one universe it is there, and there's a version of you seeing it over there, and the particle is also in another universe in a different location with another copy of you seeing it at that second position. Each one of you sees one outcome. Each one of you is fooled into thinking there's a single universe, even though there are two universes with two of you. Those parallel realities come into existence simultaneously.
And I understand the bubble portion of the parallel universes. I can see that. I can vision that. Is it possible the universes, these multiverses, if they exist, they aren't stuck together like bubbles, but there's something separating them?
Well, even in the one with bubbles, the space between the bubbles would be filled, according to the theory, with a substance that gives rise to a repulsive push. It's kind of a repulsive gravity that would push these bubble universes apart at fantastically high speed. So they wouldn't really be stuck together.
Okay.
They would be sort of embedded in the same substrate, but they would largely be racing apart from one another at fantastic speeds.
But if you have two universes, let's just say two of them,
yes,
and they're separated, what's between them?
Well, in the multiple Big Bang scenario, I can answer that. It's something called an inflaton field. It's a fancy name that just describes a kind of energy that can fill a region and give rise to repulsive gravity. But in the quantum multiverse, the one that I was just mentioning that comes from Hugh Everett and his studies of quantum physics, I don't really know what to say in terms of what's between the universes.
It's baffling.
Well, it's almost not a fully well-defined question in that case. There are these two universes. They both exist, but they don't exist in a common space in any real sense, in any sense that is akin to the space that you see in the room where you're now sitting. So mathematically, I know where they sit. They sit in a very particular kind of mathematical structure. For those listeners who know this language, they sit inside of a Hilbert space. But if you don't speak that language, they're really just these universes that sit in an abstract environment with no real sense of being able to traverse a separation between them. That's an idea that doesn't even apply to those universes.
All right, hang with us. Brian Greene, our special guest author, The Hidden Reality. I'm George Norrie. Back in a moment on Coast to Coast AM. And our special guest tonight is Brian Greene, physicist. We're talking about his latest work, The Hidden Reality. Why did he write it? Let's find out when we come back on Coast to Coast AM. And we're with Brian Greene. Brian, why did you decide to write The Hidden Reality?
Well, two reasons. First, I think it's really vital for the general public to be able to have a window onto science in the making. I mean, so many of us, when we took science in school, we learned it from a textbook that only had material that had long since been discovered, often hundreds of years before, confirmed right there, and not in the context of living, breathing discovery. So that's part of what motivates me to write on the things that we scientists are thinking about today. The other is simply this. If the idea that we're part of a multiverse is right, it is a huge if. It is an idea that I know not only explore in the book, but I really ask the difficult questions about in the book. You know, is this science? How can we test it? How will we ever know? Those are the kinds of things that I discuss in The Hidden Reality. But if indeed it is the case that we're part of a multiverse, I can't imagine a greater and more profound upheaval to our understanding of the very nature of reality. How thrilling would that be?
Oh, absolutely. And there's just so much we just don't have the answers for. So much.
Yeah, without a doubt. Without a doubt.
Let's go back to the beginning of when parallel universes were starting to arise. You talked about the 1950s. What happened? How did they start working on this?
Well, again, it was this one individual who had the genius and the boldness to suggest this possible way of thinking about quantum physics, that every possible outcome allowed by the quantum laws would actually happen. And, I described it earlier in terms of the position of a particle. Now, when you hear that a particle could be here or there and that it might occupy both of those locations in two different universes, that might sort of tickle your brain a little bit, but it may not feel all that relevant to your picture of reality. But let me just point out, every thought that you've ever had, everything you've ever done, every sentence you've ever uttered amounts to the motion of particles going this way or that, going left or right, going up or down. Every thought is the motion of particles in your brain. So when we're saying that every possible outcome allowed by the laws of physics, the laws of quantum physics, is realized in its own separate universe, we are talking about every possible thought, every possible decision being played out one way or another in these separate realms. That is mind-boggling, but that's what comes directly from the mathematics of quantum physics. Again, doesn't mean it's right. It's controversial. There are other approaches to quantum physics that don't involve parallel worlds, but this is the first one, and it's one that we are still struggling with today to try to figure out, is this correct?
You, of course, love string theory. That's part of your main area of expertise. Did that help solve some of the dilemmas of parallel universes?
Well, first I would say that love is not exactly the word I would use. I think that string theory is our best approach to trying to realize a dream that Albert Einstein himself articulated, which is to find a unified theory of physics, a theory that might describe the big, the small, everything in between, in essence from one idea, one master principle, one basic equation. And string theory is the approach that I and many others have been following now for a couple of decades. But I need to underscore, string theory, like these ideas of parallel universes, has not been experimentally tested. It's not been experimentally confirmed. And I won't believe it, I won't truly love it as something within science until it does receive that kind of experimental support.
What will happen, Brian, in order to get science to say, without a doubt, there are parallel universes out there?
Well, here's one possibility where we could get the kind of experimental support that I'm talking about. This image that we painted earlier of these many universes coming from the many Big Bangs, I said that typically two such universes would be moving apart from one another very quickly because the intervening space would be repulsive. Repulsive gravity would push those universes apart. But here's the thing. If two bubbles in this cosmic bubble bath of universes, if they form close enough together, there won't be enough intervening repulsive force to move them apart fast enough. And they may expand into one another. They may bump into one another. Two universes, in essence, may crash into one another. How would we know that if that had happened? Well, there is heat in our universe called the cosmic microwave background radiation. This is heat left over from the fiery Big Bang. When something's very hot and it expands, it cools off.
Sure.
The same thing's happened in our universe. Now, if our universe had been hit by another, that collision would generate ripples. Sort of like when you throw a pebble into a pond, you create ripples. That universe hitting us would create ripples in the heat left over from the Big Bang, and we should be able to see the pattern of those ripples by looking at tiny temperature differences in that heat. Now, astronomers are now looking into the deep space, into the sky, to try to measure in fantastic detail the temperature of the heat, and they're looking for the patterns that I'm referring to. They have not found them yet, but in answer to your question, if they do find temperature differences that fit the pattern, if they find this at some point, this would be evidence that we've been hit by another universe. This would be evidence that there are other universes out there.
Would the collision be an instantaneous explosion, or would it be more like a melding together?
Well, it'd be a little bit more like a melding in the following sense. It's not as though we need to worry sitting here right now that we're going to get hit by another universe and say we're all going to be extinguished in some conflagration. That's not the kind of thing that would happen.
And would we even see it?
Well, we could see it through these ripples, but it's only through that sort of subtle effect that this kind of collision would be in evidence.
Well, now, this brings up an interesting question. Assuming there are parallel universes all around us, are they so vast that we can't see them with telescopes? Or are they in other dimensions and we'll never be able to see them? We may be able to sense them through, as you just said, readings.
Both of the above. I would say both of the above. So in the case of the multiple Big Bangs, it would be your first description, that the universes would just be so far away that there's no capacity for light to even travel between them. No signal can go from one to the other, and therefore you wouldn't see them. However, there are other versions of the multiverse proposal where the other universes might be right next to us. In fact, you asked about string theory. Let me give you one of the parallel universe proposals that does come from string theory. So one of the ideas from string theory is this. We used to think that the only fundamental ingredient in string theory were little tiny filaments that look like strings. That's why we called it string theory. And the idea was that inside of all of the fundamental particles, electrons, quarks, name any particle that you've ever heard of, inside of it, according to string theory, would be one of these little tiny vibrating filaments. In the mid-1990s, we realized that those little filaments are not the only ingredient in string theory. There are also membranes, big two-dimensional surfaces, big three-dimensional blobs that we call three brains, borrowing the brain from membrane and putting a 3 in front of it, and so on and so forth. These extended objects we found in the math of string theory. This raises an astounding possibility. All that we have long thought to be the universe might actually be taking place on one of these brains. The picture to have in mind is, think of our universe as a big, huge slice of bread in a large cosmic loaf that has other slices of bread nearby us.
Okay.
Now, those other slices could actually be a tiny fraction of a millimeter away from us, but in another dimension. And we wouldn't be able to see those other slices of bread, those other universes, because light, photons, the thing that we use to see, would be trapped on our slice of bread. The math shows that light would not be able to traverse the gap through this other dimension. And therefore, these other dimensions would be a barrier to seeing these other universes, even though the other universes are right next to us. We can't reach off, we can't see, but nevertheless, they are there, according to this approach.
The Kepler Satellite Telescope is looking into 13.2 billion years ago. Pretty darn close to the beginning of the Big Bang. If they ever get to a point, Brian, where they can go beyond that, might they see a collision of parallel universes?
Yes, in fact, we don't necessarily have to look quite that far back. We need to look at the microwave background radiation, and that's about 300,000 years after the beginning, after the Big Bang. So we don't actually have to look back right to time zero itself. And this is something that we do with a variety of telescopes and satellites. You may have heard of the WMAP satellite.
Yeah.
Or the Planck satellite. These are satellites orbiting in space that are taking fantastically precise measurements of this heat that was generated 300,000 years after the beginning of our universe. And it's in that data that we stand the greatest chance of being able to see a glimmer of an interaction with another universe.
Tell me about dark energy. Exactly what is that?
Well, dark energy is, I'd say, the greatest mystery that physics faces today. It is not a hypothetical idea that we are playing with. It's something that really comes from observational data. And the observations are this. We have known since 1929 that the universe is expanding. But everybody thought that the universe would be expanding but slowing down in its expansion because gravity typically pulls things together.
Right.
If you throw an apple up in the air, it goes up, but it goes up slower and slower because gravity pulls it back toward the Earth. We thought that the distant galaxies would be rushing away slower and slower too. Two teams of astronomers, however, measured the motion of those distant galaxies and found quite the opposite. They are rushing away faster and faster. The universe is speeding up in its expansion, completely unexpected. It's as if I took that apple and I threw it up in the air, and it went up faster and faster. Now, if you saw an apple go up faster and faster, you conclude something must be pushing on it.
Something's pushing it, right?
Similarly, something must be pushing on those distant galaxies.
Or pulling it?
It could be pulling, but pushing is the one that we have a better explanation for.
Okay.
And it comes to the dark energy that you mentioned. If the universe, if space is filled with an energy that's uniform, doesn't give off light, that's why it's dark energy, then the mathematics that Einstein gave us shows that that energy can give rise to a repulsive gravity, a repulsive outward push. And it's that repulsive gravity, we believe, that is pushing those distant galaxies away from us. So we now suspect that there is this energy that is throughout all of space. We actually can measure how much energy there is. It's about 70% of the weight of the universe. So most of the universe, in some sense, would be in this form of dark energy. And it's our charge to try to understand this energy better, to understand its properties over time, and ultimately to analyze what it is made of in detail. And these are mysteries that we have not yet resolved.
Brian, could we use this dark energy as a propulsion system for spacecraft?
People have tried to come up with ideas along those lines. I don't think it's possible. I don't think that we can harness this dark energy in that kind of a manner.
Okay.
But who knows? Maybe I just don't have the creativity to see how to do it. But I don't see how it's possible.
All right. Because I keep thinking if there are space travelers out there, they must have learned how to bend space and time, because there's no way they're going to travel without it.
Well, if you believe Star Trek, warp factor 3 is associated with doing just that. So, but I don't really know of a way to harness the dark energy for that purpose.
You cover about 9 variations on the multiverse. Let's go through some of them real quickly.
Yeah, sure. The first one that I discussed in the Hidden Reality is a version that is the simplest of all, really, to discuss, and it relies on the possibility that space may go on forever. I mean, if you got in that rocket ship and you went off into space, would you ultimately hit a brick wall? Most people don't think so. Would you circle back to your starting point, sort of what would happen if you went off on the surface of the Earth far enough? You'd come back to your starting point? It's possible, but there's no evidence for that. Many physicists and astronomers think that if you got in that rocket ship, you'd simply go on forever. Now, if that is the case, there's a startling conclusion, and it arises from the following consideration. In any finite region of space, matter can only arrange itself in finitely many distinct configurations. It's like if you have a deck of cards. That's my favorite analogy for this. If you shuffle the deck, the cards will come up in many different orders, but there are only finitely many distinct orders for cards in a deck. So if you shuffle that deck enough times, infinitely many times, the order of the cards have to repeat. Similarly, in an infinite universe, the configuration of particles must repeat too. Now, if the configuration of particles repeat, what would that mean? Well, we are just particles, right? Everything we know of are just collections of particles. So reality would repeat out there. So this is the origin of that version of parallel universes that we were discussing earlier. It's a simple fact that in a finite region of space, only finitely many distinct particle configurations, so there would have to be copies of us out there. This is the reasoning that leads to this spectacular conclusion from a simple assumption. Now, the assumption could be wrong. Space maybe is not infinite, or maybe way out there in space, different laws are in effect, so we can't really make any predictions for what happens out there. But there's no evidence for any of these ideas, so the simplest conclusion would be that space does go on infinitely far, and the laws of physics are the laws that we are familiar with, and this bizarre conclusion would follow.
That's dramatic. As you came up with some of these thoughts on these different variations, I mean, were some of them based on speculation, or was there some science behind it?
Well, there's always speculation, but I'm not interested in any for which there isn't science behind it.
Right.
So the example that we discussed, we're using the basic laws of physics with an assumption that space goes on infinitely far. In the multiple Big Bang one that we discussed earlier, again, it's coming from mathematics that was developed to understand the origin of our universe, and then, surprise, surprise, when you study that math, it says there may be other Big Bangs, other universes. The multiverses that come from string theory. Again, string theory, as I said, is speculative, but it comes from trying to understand Einstein's theories of gravity and quantum mechanics in one consistent framework that leads us to the laws of string theory, and you study the mass of those laws, and it suggests these possible brain universes, the slice of bread universes that we were discussing just a moment ago. Quantum physics, well, that's math that's used to describe molecules and atoms. It really works. It makes predictions that are testable and confirmable. And yet, when you study that math, one approach suggests that there are these many universes coming from the many possible outcomes of experiments. You see the pattern. We study math. That's a common thread through all of these ideas. And then math leads us time and again to at least consider the possibility that there are other universes.
You know, I've always had the belief, Brian, that everything has a purpose or wouldn't be here. A mosquito has a purpose. Your book has a purpose. Everything has a purpose or it wouldn't be here. So as you look into the cosmos, you got to try to figure out what's the purpose.
I wish I had something intelligent to say on that. I mean, I agree with you in the sense of we as a species have been on the very quest that you're talking about. We have tried for thousands of years to figure out why are we here? What's it all about? Why is there something rather than nothing? And science at least helps us understand the basic context in which those questions are asked, the universe or the universe is, if some of these far-out ideas are correct. But I don't think it's really given us much headway in the kinds of questions that really drive the human soul, if you will, the questions that speak to meaning. There are other approaches, of course. People turn to religion. People turn to various kinds of New Age mystical ideas in order to fill in this yearning that we have for meaning. I don't think science in of itself fills it in the way many people seek. But for somebody like me, I have to tell you, it's enough for me to understand the hows. It's enough for me to understand how perhaps the universe came to be or how there may be other universes. That's satisfying for me enough. I don't feel the need to go further and try to find a deeper purpose beyond that which comes from the laws of physics. But, that's a scientist perspective.
Do you find that these laws of physics, laws of the cosmos, that they are the same, they don't change?
Well, they can change if you envision multiverses that have a certain kind of complexity and robustness. So in the quantum multiverse that we were describing, with the many possible outcomes, each happening in its own universe, no, the laws of physics would be the same, universe by universe by universe. In the example where space goes on infinitely far, we are imagining that the laws of physics are the same in each realm. They don't change. But in the multiple Big Bang scenario, the laws of physics could manifest themselves in very different ways in the different universes because the environments could be so different that there wouldn't be any direct evidence from a casual view of an inhabitant in any given universe that there were the same laws of physics. They would have different particles. They would have different forces. That would seemingly be different laws. There's even a more far-out idea, frankly, that I discussed at the very end of The Hidden Reality. It's not an idea that I really believe in, but I thought it was useful to include, which is the possibility that some have thought about that maybe all of mathematics is realized universe by universe. So I said before, if you go to a math library, you pull a book off the shelf, there are a lot of equations in there. Most of them have not found their way into our laws of physics. But some have suggested that maybe every mathematical truth is realized in some or another universe. And then the laws of physics in those universes would be completely different. They'd be governed by completely different mathematical equations.
Brian, it's difficult. We talked about the Y factor. It's difficult to comprehend one universe. It's even more difficult to comprehend two and to try to figure out why there would be more than one. Where do we go from there?
Well, I think where we go from there is twofold. We have to keep pushing on our mathematical understanding of these possibilities so that we can describe the other universes, if they exist, with enough precision that we can start to make some definite statements, such as these universes would likely have this or that property. These universes would definitely have this or that kind of force in operation. Statements like that would ultimately allow us to then go the next step, which is hopefully to test some of these ideas. I mean, let me give you an example. You might think other universes would necessarily be untestable, unless they, say, collided with us in a manner that we discussed earlier.
Right.
But imagine that you have a very well-developed mathematical multiverse proposal that says something like this. All these universes are out there. They differ in many ways, but they all share the following property. They all have the following collection of particles with these particular features. Well, since we're part of that multiverse, that statement must also apply to us. So how do we test it? We go look for those particles here in our universe. If we don't find them, we rule out that whole multiverse proposal is falsifiable. If we find those particles, well, that's one piece of evidence that this theory may in fact be correct. That's how science progresses. But it does require that we understand the mathematics of these theories fantastically well. That's what we're working hard to do now, and ultimately be able to test some of the ideas that come out of that mathematics. That would be the next step.
I would like to think that also some of these other multiverses would have rectangular planets, square planets, but I don't think they do. I think everything's the same. I think it's pretty uniform.
Well, it's funny that you should give that example because I'm also working on with Nova. We're working on a 4-part miniseries, and one of the hours is focusing on the possibility of other universes. And what the artists came up with is exactly what you said. In order to visualize the other universes, they had some rectangular cubic planets, going around a cubic star. And it's not impossible because anything that would be compatible with the laws of physics could happen. And in principle, that might be compatible with the laws of physics. However unlikely, maybe there would be only very rare universes which would have that property, but it is at least within the realm of possibility.
We talked earlier about the end of the universe, Brian, and, if you got to the end of our universe, would it be like inside of a bubble or a balloon trying to come out? Would you feel that kind of pressure to get through to the other side, or what's the end like?
Surprisingly, you wouldn't find that, and it's natural that you would think that, especially in the description that we've had, where we are envisioning our universe to be what looks like a bubble, an expanding bubble. But one of the weirdnesses that Albert Einstein figured out with his theories of relativity is that one's perspective of space and time can differ from somebody else's perspective of space and time. And that comes in with a vengeance in these multiverse proposals, and here's why. From the outside, from the bird's eye view of these multiple Big Bang universes, indeed each looks like a bubble that's expanding. But if you are inside one of those bubbles, it turns out that your understanding of space and time differs from the outside perspective, and inside it looks like space goes on infinitely far. There is no edge to the bubble that you could ever encounter. The edge, it turns out, is a moment in time, not a place in space. The only way that you could encounter the edge would be to go back in time, and that's something which we don't think we can do. So surprisingly, inside one of these bubble universes, it would look like space goes on infinitely far, no edge to encounter whatsoever.
Let's go to some calls here, Brian. Nick in Pittsburgh, Pennsylvania. Hi, Nick. Welcome to the program.
Oh, hi, George. Thank you.
Sure.
So I had a question about the God particle.
Yep.
The Higgs boson particle, it's called. I thought that there might be different theories for gravity besides having a particle, and you started talking about the dark energy, which is you said some of the farther galaxies are they're actually moving away from us.
Mm-hmm.
So could gravity be caused by if you had a square box that was the universe, and you had a particle right in the center, and space and time were expanding evenly all around that, then that would create a pressure all around it evenly and holding that one atom in the center. But if you put a second atom at a distance away from that, space-time was expanding evenly all around them, except there's less space-time expanding between the two atoms, which forces them to go together.
Sure.
But,
I think I basically understand what you're saying. I think the point that really needs to be emphasized is that it's not that the expansion of space itself creates a force that the particles within that expanding environment feel. It's quite the opposite. We need to put our finger on the force that causes the expansion itself to happen. And that we do think comes from gravity. We do think it comes, as I mentioned earlier, from the possibility of gravity being repulsive, something that Isaac Newton in the 1600s would never have thought of. For him, gravity was only attractive. That apple fell from the tree and hit him in the head. That apple did not rush up into space. But nevertheless, our more refined treatment of gravity from Einstein shows that gravity can be repulsive, and it's that force that we think is responsible for the expansion of space. It's not that the expansion of space somehow itself creates a force that particles feel.
What would Isaac Newton do today with a knowledge of mathematics and a computer on his desk?
Oh, boy, that's spectacularly exciting and frightening. I think that when you take an intellect like a Newton and provide him with the modern tools that we have at our disposal and the modern insight that's happened over the past 300 years, I suspect in short order he'd revolutionize everything.
As they talk about heaven and hell, Brian, is it possible that what they might be talking about are these parallel universes that have these different complexities?
I don't think so in any conventional view of what heaven and hell are. heaven and hell, at least as I have encountered them in the various scriptures, are realms that, in principle, we could migrate to. They're realms that, in principle, we could be forced to enter or that we might joyfully enter. But the other universes that I'm talking about, the ones that I discussed in the hidden reality, are generally places that you can't visit. The laws of physics don't allow you to actually traverse the space between the universes, if that's even a well-defined concept. And if it's not, then there's no even sense in which you can jump from one universe to another. So however much there might be a parallel, roughly speaking, between those ancient ideas and these modern ones of parallel universes, I do not think they're the same.
Next up, we go to first-time caller Newton Falls, Ohio. Hi, Brad.
Hey, George. How you doing?
Okay.
Good. I just have one question for your guest.
Sure.
I was just wondering if there are any paradigms beyond positivism that you and the quantum physics research community have kind of explored to kind of get at the why these things happen beyond the regular physics and these kinds of things. Thank you.
Well, look, quantum physics is spectacularly strange. And since 1925 or so, we have been struggling to figure out what it actually says about the nature of reality. It is very odd to have a theory that only talks in terms of probabilities of outcomes. It's very strange to have a theory that talks about waves of probability, the possibility of particles tunneling through otherwise impervious barriers. I mean, all of these are very, very strange features. The thing that I want to emphasize is they're strange to us because we don't directly experience these phenomena. We are too big to actually experience the weirdness that becomes manifest in the microscopic realm. I like to say if we were born, not our typical size, but if we were born 10 to the minus 18 meters tall, and we spend all of our lives walking around at that size, these strange features of quantum mechanics would be intuitive. They would be as intuitive as what happens when you drop a glass. We all know it falls to the ground. If we lived and we were tiny beings, 10 to the minus 18 meters tall, all of the weirdness of quantum mechanics would be so intuitive that we wouldn't cry out for a deeper explanation. It would just be the way reality works. So part of the challenge for human beings is to get over the intuition that comes from everyday experience and recognize that there's a deeper reality that has been revealed to us by mathematics and has been confirmed by experiment. And sometimes that deeper reality doesn't need a further explanation once you have rigorous mathematics that can make predictions.
And Brian, to date, there hasn't been a multiverse proposal that has knocked your socks off, right?
Well, I think they all knocked my socks off, but if what you mean by fully knock my socks off is convince me that
Take
it's
them
real,
off, right?
then you're absolutely correct. In fact, in the opening pages to the Hidden Reality, I come right out and say that. I say I am not convinced that parallel universes are out there. I say, however, that I am convinced that the math is so compelling that it's worthy of attention and it's worthy of exploration, and it's also worthy of exploration because if it is true, it is so spectacularly amazing. But until it has observational support or experimental confirmation, no, I will not believe anything until it enters that domain of confirmable fact.
How many scientists out there, Brian, would say this is way too far out?
There are many who would say it's way too far out, but the thing that I should emphasize is there are many who would say this is an idea that is sufficiently potentially real that we're going to spend a chunk of our professional lives researching it. This is not a fringe idea within the physics community. Some of the greatest minds of the late 20th, early 21st century physics are spending their professional days thinking about this possibility. So however far out it may sound, it is sufficiently compelling and sufficiently possible that some of the bread and butter physicists who have pushed our understanding to where it is today are thinking about it.
I think it's exciting. The possibilities are exciting.
Spectacularly so.
Let's go to San Antonio, Texas. Sharon, it's your turn. Hi, Sharon.
Hi.
Hey.
Well, you made reference to Albert Einstein quite a bit, and reading about his faith in God, it helps my faith. And I believe God is infinite in that he's created layers upon layers of knowledge for us to discover for, one reason or another in time. And so we can keep learning, keep growing, and reaching into new ideas and new worlds. And that being said, how does knowledge of parallel universes benefit us? And do you think we will ever access the technology to make this knowledge useful?
Well, let me make two comments. The first, with regard to Einstein and religion, Einstein had made a number of famous statements that are often quoted that refer to the old one, meaning God, or the famous statement, God does not play dice, as his response to quantum physics. He often invoked this notion of God. Now, when you look more closely, I think it's pretty clear that Einstein was really referring to a kind of pantheistic notion of God, a Spinoza-like notion of God, where what he really meant was the order, the harmony in evidence in the laws of physics. So I personally don't think that he really had the traditional image of the God with the white beard when he was referring to God, but rather this more vague and general notion of the order and harmony that really is in evidence in the laws of physics. Now, in terms of parallel universes and what it might do for us, I don't think it would do much in the sense of new gadgetry or solving the world's problems. I don't think it's that kind of a development, but I think it would completely change our sense of who we are and how we fit into the big picture. I mean, for thousands of years, we have been searching. Philosophers, poets, musicians, scientists, we've all been seeking the true nature of reality from different perspectives. If science can weigh in and say, here is the canvas, the broad canvas on which the totality of reality is painted, I think that would really have a ripple effect for centuries in how we consider how humans fit into the cosmic picture.
I think so, too. Let's go next to Randy in Palmdale, California. Hi, Randy. Go ahead.
Hi, George. How are you?
Good. Thank you.
Yes, wonderful show tonight. I have a couple of things that I would like to say. One is that, if you look into ancient Buddhist texts, the ancient Buddhists, they consider the universe to be unfathomable.
Mm-hmm.
Okay? So the universe but Buddhists, when they become enlightened, they understand this. And it's through enlightenment that they realize, for example, in the Lotus Sutra, there are two chapters. One is the chapter where the Buddha he explains the nature of his enlightenment. Then the 16th chapter of the Lotus Sutra, he explains the time period in which he attained enlightenment, and it's incredible because he says if you were to take a major particle, if you were to take every major world system in the universe, meaning like a worlds or a galaxy, and you crush them to particles of dust. Then you proceed in any direction throughout the universe, and you drop every particle to every new world that you encounter. He says you will not have scratched the surface of understanding the beginning of time. And so that's what I wanted to say. And I also wanted to ask your guest, what fuels the universe? What is the fuel? Is it dark matter or is it something else? Thank you.
Well, those are two interesting points, and maybe we're saying a word about both. I was involved in an event a few years ago with the Dalai Lama. It was actually down in Texas, and he and I got into an interesting conversation that unfortunately was cut short by, I think it was Hurricane Rita back then, that caused everybody to ultimately cut short the proceedings that we were down there participating in. But I did ask him in a public setting whether he thought that some of these ancient approaches, Buddhist texts, Hindu texts perhaps, were giving deeper insight into the nature of how the world is put together than what we have been discovering through modern science. And he was very forthright. He said no. He said, you guys, you physicists need to keep telling us how the world is put together, how the universe is put together, what are the fundamental laws, what are the fundamental ingredients, and we need to incorporate your findings into our worldview. What he did say, however, is when it comes to consciousness, that he felt strongly that it was the Buddhist tradition that had gone further than Western science, Western medicine, to really understand the nature of consciousness. And he said that's where the modern science, the modern doctors need to learn from these more ancient-based perspectives. But when it comes to physics, he was pretty clear. It's from the West that we really need to learn about the cutting edge of understanding. Now, for the second point, in terms of what fuels the universe, there are many ways to ask and to address that question. If you're talking about what drives the expansion of space, then it is the dark energy that you described. Dark energy, as I mentioned earlier, we believe does give rise to repulsive gravity that we suspect is what's driving the galaxies apart. But if you ask that question more deeply in terms of why is there anything at all? Why is there something rather than nothing? Where does that energy come from? I don't have an answer for that, and nobody that I know of does. There could have been a universe of truly nothing. I don't mean empty space. There could have been literally nothing. Why isn't that the case? This is what Leibniz asked 300 years ago, and I don't have the answer. I don't know.
What did you think of the Dalai Lama? Quite a gentleman, huh?
Not only quite a gentleman, it was so refreshing to be in the presence of somebody who was so secure in his own knowledge of both himself and his knowledge of what his perspective could reveal about the nature of reality, that he wasn't threatened by science. He wasn't threatened to say, keep on bringing it on, scientists, because we want to know what you are thinking, because we want our views to align with the scientific perspective. That was so refreshing.
Brian, we're going to come back in just a moment and take more phone calls with you. Brian Greene, the author of The Hidden Reality. That'll be next on Coast to Coast AM. And our special guest, Brian Greene, right here on Coast to Coast AM. And we'll be back with more of your phone calls in just a moment. Don't touch your dial. Brian, the book, The Hidden Reality, is it out there in the bookstores now?
Yes, it is, absolutely. And, in fact, it'll be number 4 in the New York Times bestseller list this Sunday, so it's doing pretty well so far.
It'll be number 1 after this show, probably. Good for you. Good. You enjoy writing, don't you?
Well, it's a great challenge to try to take these ideas, which are wholly mathematical, and express them in a way that has no math. I mean, most people don't speak mathematics. Most people don't feel comfortable with cutting-edge mathematics. So I see myself in writing these books as basically translating from the realm in which the thinking and the research is done using one language, mathematics, and trying to express it in ordinary English, using stories, using anecdotes, trying to make it entertaining here and there, and basically trying to make it so that the average person who doesn't have any technical training can get a sense of what these ideas are about.
When you talk about the laws of the cosmos, who created those laws?
I don't know. It could be that the laws simply are. It could be that the laws are dictated maybe by logic alone. Maybe logical necessity brings the laws into existence. I just don't know. I mean, of course, some would say maybe ultimately you are forced into introducing some other entity, some divine being that decrees the laws of the universe, and then those laws take over and allow everything to unfold in the way that we have discovered. Hard to rule that out. No evidence for it. But it does present a puzzle. Where do the laws come from? What breathes life into certain mathematical equations? I don't know the answer.
How important has technology been for you, Brian? The computer
Critical.
And things like that.
Absolutely critical. I mean, there are calculations that I've done in my own research that would have taken, by using pencil and paper, would have taken hundreds of years if you actually tried to do it by hand. But we have computers, and we have some spectacularly powerful programs that people have developed. Something called Mathematica is a spectacular program that allows us to do calculations on a computer that you just couldn't do any other way. So from that perspective, the technology has been vital. It's also vital for the experimental data. The fact that we can, in Geneva, Switzerland, slam protons against protons near the speed of light and track the debris from those collisions to fantastic precision all comes from technology. You know, the fact that we can have powerful telescopes orbiting in space, looking back right to the very beginning of our universe. Wow. I mean, all of this comes from the technological revolution of the last 50 years. It's great. It's fantastic.
What is the next evolution telescope?
Well, there is this James Webb Space Telescope that, in fact, we had a full-scale model of it at the World Science Festival, this festival for science that I co-founded. We had a full-scale model of it in Battery Park in New York City last June. And funding permitting, that will be the next generation of space telescope, allowing us to peer yet deeper and with greater precision into the cosmos.
Will we see that Big Bang?
Well, it's very hard to literally see the Big Bang because of this microwave background radiation that we were talking about.
Right.
That creates kind of a fog, if you will, at about 300,000 years after the beginning, and it's very difficult to see through that fog. However, some things can penetrate that fog. For instance, gravitational waves. Waves of gravity can potentially penetrate that fog, and one day we may be able to use that kind of a probe to peer back to the bang itself. It's not impossible.
If this happened 14 billion years ago, why are we as a planet only 4.5 billion years old? And I'm sure there are some that are older, there's some that are younger.
Well, that we understand fairly well. So for a few billion years, what happened was the early generation of stars formed, and those stars exploded, allowing yet more complex atomic structures to be spewed out into space, and they coalesced in dust clouds, and next generation stars formed, and our Earth is part of the coalescing of the dust materials from early generation stars. So the fact that we have on Earth a wide variety of atomic species, the fact that you and I are made up of a wide variety of atomic species really owes itself to those atomic species having formed in stars that then went supernova and allowed the material that they brought into existence. Stars are basically nuclear furnaces, and those furnaces cook up atomic elements. And the fact that those atomic elements are then spewed out in supernova explosions allows for the ultimate production of planets and the structures on planets like you and I.
Brian, had there not been life, at least on this planet, all of this would have been for naught. What good would it have been?
Point.
We wouldn't be here to know about it.
In fact, you can even go further than that. If a big meteor hadn't wiped out the dinosaurs, then the dinosaurs might still be roaming the planet. So there'd be life, but there wouldn't be the kind of intelligent life that can reflect on itself and reflect on the origin and evolution of the universe. So it's an interesting question. We always talk about, is there life on other planets? But the second question is not just life, is there intelligent life?
That's right.
Because without that meteor, we might not have been here, and it might still be the dinosaurs.
Everything had to happen precisely.
Yes. And how often does it happen throughout the universe? I don't know. Is it a one-off? Are we the one-off intelligent life in the cosmos or not? Nobody knows, of course.
West Hartford, Connecticut. Bill, it's your turn, and thanks for holding, William.
Yes, hi, Brian. Hi, I'm an amateur astronomer and an atheist myself, so I understand cosmology. I have two quick questions for you, and question number 2 is going to knock George Norrie's socks off, coming from me, an atheist. Wait till he hears it. Question number 1. You mentioned Planck, the satellite that is observing the leftover radiation from the Big Bang. The ultimate data is supposed to come out in late next year, 2012. Question number 1, do you think that Planck will give us the first testable evidence for gravity waves from another universe, meaning proving the multiverse? And question number 2, the major one, since you said that every atom, every molecule and atom is made up ultimately of strings, that includes me, my body, your body, George Norrie's body. Could it be, looking at the subject of near-death experiences or life after death, instead of from the point of view of heaven or hell, as a religious person, I think, wrongly conceives it, could it be that our brains, the atoms and molecules in our brains, in other words, the strings in each of the atoms and molecules in our brains, could they live on into an energy dimension? Because energy cannot be created or destroyed, so you don't need a God to create our minds, what a religious person would call soul, but also the energy cannot be destroyed. So could the strings in our energy, in each molecule in our brain, live on in another universe? You see what I'm trying to say, scientifically speaking?
Sure. So for the first question, in terms of would the Planck satellite possibly see evidence of gravitational waves, you framed it in terms of from another universe. It wouldn't necessarily be from another universe. This possibility of universes colliding, giving rise to these ripples in the cosmic microwave background radiation is a long shot possibility. But a more likely outcome of the Planck data would be evidence in the cosmic microwave background radiation for gravitational waves, and that would be very exciting. We really don't have any direct evidence yet. That would be the first. That would be enormously exciting. There's some indirect evidence for that from the WMAP data, but Planck could really nail the case, which would be great. Your second question in terms of what happens to the energy in the particles, or string theory is correct, in the strings that make up us. Well, I agree with you. When a living being dies, the energy that being embodied is not lost. I believe it does persist. It persists, however, in a form that doesn't have the coherence that it had when that being was alive. So I'm not sure what we can read into it. We definitely, in some sense, could, in principle, follow all of the energy that makes up a person and what happens to it after that person dies, but it won't embody in any realistic sense the consciousness of that person. It won't embody the things that we ordinarily associate with that individual, the things that make that individual distinct. So you could say that we all live on by virtue of the energy that we embody carrying on as well. But I don't know that energy in any way can really be associated with us in any distinctive way after we die. So from that perspective, I don't think it buys us very much.
Okay, Bill, thanks. Next up, let's go to Joe in Toronto, Canada, east of the Rockies. Joe, go ahead.
Hi there. I'd like to ask Brian what he thinks about this theory and a possible test. The fact that feeling that there's another universe out there, that because humans have electric charge, the other universe is sending signals to operate a human. The test would be to insulate a human with some kind of insulation or a helmet to see if that person operates differently. Like yesterday, for example, in Toronto, I really think that people are around fiber optics and electric charges. I believe in God, and I believe that basic good. But the fact that there was like broadcasters in Toronto here that were just attacking the poor based on Arnold Schwarzenegger coming here last week and panning poor people. And
hey, Joe, I got to get you on topic here. What's your question?
I guess the issue is to be able to, insulate someone to test whether or not, the electric charges from a parallel universe a person would operate differently.
Yeah, I don't think so. First of all, I should say that while the particles that make up people, such as electrons and protons, do have electric charge, we collectively are electrically neutral. We typically have roughly, to high precision, I should say, the same number of electrons as we do protons, which cancel each other out. So we are not carrying a net electrical charge. So, A, that part of what you're saying doesn't quite hold water, and B, the notion that somehow we are being manipulated by electromagnetic forces from another universe is so far outside any of the ideas that come from the mathematical investigations that I'm describing that it isn't really worth contemplating in detail. But let me just point out one thing that does resonate a little bit with what you say. We believe that there is a certain amount of dark matter, not dark energy that we discussed earlier, but also dark matter in our universe. We know that because when we look at the motion of stars and galaxies, the stars and galaxies are moving so quickly that they should be flying apart. And we believe that they're not flying apart because there is additional matter out there providing additional gravitational pull, but that matter doesn't give off light, and that's why we don't see it. Could that dark matter be residing on a parallel universe? Well, this actually is an idea that I take up a little bit in the hidden reality, because in this brain multiverse that comes out of string theory, people have suggested this is a real possibility. If there indeed is another universe hovering, less than a millimeter away that we can't see because light, as we discussed earlier, can't traverse the gap, it is possible for gravity to traverse the gap. That comes directly from the math of string theory. So it's at least possible that you could have matter in a nearby universe giving rise to the additional gravity that we know must be operating out there in the cosmos to keep the stars and galaxies from flying apart, but we wouldn't see that matter if it was on a nearby brain because, as I mentioned, light can't traverse the gap. That is a real possibility. I've never seen a model that works in detail, but at least the notion of gravity, not the electromagnetic force as the caller was suggesting, but gravity traversing the gap between universe and universe, that is a possibility, yes.
If we can't see it, Brian, could we still be able to physically touch it?
Well, touching is an interesting word because whenever we touch something, we're exerting some force.
Right.
When I touch the table in front of me, I'm touching it by virtue of the electromagnetic force. It's the electrons in my fingertips repelling against the electrons in the atoms of the table that gives me the sensation of touch. But you can touch using other forces. You can touch using the gravitational force. It's a much weaker force. That's why we typically don't use it when we manipulate objects in the world around us. But it is a force that we could use to probe these other universes in this brain multiverse setup. So if you include in touch using the gravitational force, then the answer would be yes.
Opelousas, Louisiana on the wildcard line. Al, hi.
Good morning, guys. Brian, I was wondering if you could clarify my understanding of the consistent histories version of Everett's many worlds hypothesis. The way I understand it, it's like all these different universes kind of interfere with each other and are superposed according to the logical queries that we make. Is that a good understanding?
It is. It's close. So the consistent histories approach is developed by Nobel laureate Murray Gell-Mann and James Hartle at Santa Barbara and a number of other physicists around the world, and it tries to make further sense of Hugh Everett's multiple universe approach to quantum mechanics, and it does it somewhat in the way that you're describing. Rather than stopping with the bare bones mathematics of quantum mechanics, these physicists suggest that what quantum mechanics really does is it tells consistent stories about sequences of events. And if you frame quantum mechanics in that language, these scientists suggest that you're able to make much better sense of the multiple universe approach to quantum mechanics, and as well you're able to solve certain paradoxes and conundra that the traditional approaches are stymied when encountering. Many people have studied the consistent histories approach. There's a lot of controversy about it. There are people who believe it is absolutely the right way to do quantum mechanics. There are others who are yet to be convinced. I consider myself in that latter category. Maybe one day I will be fully convinced too. So it's an interesting approach. As yet, it has not really established itself as the one and only approach to quantum mechanics.
What's it going to take, Brian, to get these answers? Time?
Well, for quantum mechanics, I think it is largely time. And we have reams and reams of data that support the bare bones ideas of quantum physics, but overlaying an understanding of what that bare bones is telling us about reality, I think will take a lot of mathematical study, a lot of research, and that will take time. Do I think it will happen soon? No. We've been at it for 80 years, and there's still controversy. I hope in my lifetime we will have a resolution to some of these questions, but I don't know that we will.
Well, me too. It may be too vast to get the answers.
It may be too vast. It may be too complex. It may need a different kind of mathematical formulation than the one we have at our disposal. All of these together may ultimately yield clarity, but I think it'll be a long time in coming.
Something tells me that there's a simpler reason why it's right under our noses. We just can't feel it, see it yet.
Well, Einstein certainly thought that. Einstein thought that all of the strangeness of quantum mechanics would evaporate when we got a deeper, unified understanding of physics. And that's what largely was driving him. He felt that his unified theory would supplant quantum mechanics. Quantum mechanics would be viewed as an approximation to the deeper laws that he was seeking, even in the last minutes of his life. There's a wonderful story that Einstein was in the hospital in Princeton, New Jersey, and asked for the pad of paper on which he'd been scribbling equations in the hope that even in his final moments he would complete this unified theory. He didn't. But his firm belief was that unified theory would make all of the weirdness of quantum mechanics much more understandable.
What might he say if he were alive today and he reads The Hidden Reality?
Well, I think that he would be impressed by the developments in string theory. I think, like the rest of us, he would not be convinced of it until it has experimental support and it doesn't yet. But I think he would be impressed where we've gone. I think he would also firmly demand experimental proof, just as we're talking about in our conversation here tonight. I'd like to think, however, that he'd enjoy the hidden reality. In fact, the last chapter describes some of his own mathematical exploits and tries to tie them in to some of the mathematical discoveries that have led us to the parallel universe proposals that the book describes. So I hope that he would find it a fascinating read.
Michio Kaku would agree with you. What about Stephen Hawking?
Well, Stephen Hawking, in fact, has his own book out on the possibility of multiple universes called The Grand Design that many people have been reading. The difference between his book and mine is I take a much closer look at some of these theories and really try to bring the reader step by step through the reasoning that leads us to these various proposals. I'm not a fan of just telling people that this is where we've gotten. I want them to understand the logical chain of reasoning that takes us there.
Brian, what's your take on black holes? What are they? How are they formed? What's inside of them?
Well, black holes are a wonderful laboratory for pushing many of our theoretical ideas to their limit. First of all, what are they? Well, they're regions of space where there is such a powerful gravitational pull that if you get too close, you can't get away. Even light can't escape, which is why they're dark. They're dark regions. Light can't be emitted from them. We believe that they typically form when a star exhausts its nuclear fuel and can therefore no longer support its own weight. So the star basically collapses in on itself. It collapses, it gets smaller and smaller, denser and denser. At some point, it is so dense that the gravity it exerts has the property I described. Get too close, cross over what's known as the event horizon, and you cannot pull away. We know about black holes theoretically from the work of Albert Einstein way back in the early part of the 20th century. And in the years since, there's been a steady and increasingly convincing set of observations establishing that black holes are really out there. We, in fact, believe that there's a black hole at the center of our galaxy that weighs perhaps as much as 3 million times as much as our sun.
Jeez.
So that's what they are.
Could that suck us up one day?
You know, black holes do have this reputation for sucking things in, but the amazing thing is if you're outside a black hole, if you stay sufficiently far away, it doesn't act any differently than an ordinary star would. It exerts gravity, but you can't escape it. The only time that a black hole really becomes different is if you get too close. And then it sucks you in the sense of you're unable to escape. But as long as you're outside its edge and you don't cross over the edge, it's perfectly safe.
Could they be portals to the other universes?
Some people have suggested that. Even the work of Albert Einstein showed that conceivably you could have what's known as an Einstein-Rosen bridge, which is a wormhole, a tunnel, if you will, that would extend from our universe to another universe. Mathematically, these bridges make sense. Whether they exist in the real world is a complete unknown.
Okay, let's go back to the phones west of the Rockies. Brad is in Lincoln, California. Hi, Brad.
Hi, George. Thank you for taking my call.
Sure thing.
Brian, yeah, the black hole, I love the way you think. The black hole, too, isn't there called an accretion disk where I was reading on this website where it says the accretion disk is where all the matter is it's like a boiling hot soup of 2 trillion degrees.
That's
that
right.
was very, very fascinating. Is that true?
Yeah, so what happens is if a black hole is in the vicinity of a more ordinary star, material from that star can fall toward the black hole. And if the black hole is spinning, then that material will form a spinning disk around the black hole. And as this material falls toward the black hole, tremendous frictional forces heat up the material. It gets incredibly hot. And in fact, it typically emits X-rays. These are emitted before the material falls over the edge of the black hole. So the X-rays, light in the X-ray part of the spectrum, can escape to an outside observer such as us here on Earth. So when we see powerful X-ray sources, that often is a signature that material is infalling toward a black hole.
Okay, and then one other quick thing. You were talking about other universes and things. Well, in Scripture, Paul talks about in 2 Corinthians where it says that 14 years previous to the point, Paul was given a profound vision in which he was taken to the third heaven. And he refers to it as paradise. And it calls it also the abode of God. But what he said was the atmospheric heavens include the high clouds in the sky of our atmosphere, which is in Genesis. Then the second heaven involves outer space beyond our atmosphere and the abode of the galaxies, visible to the great telescopes. And it says the third heaven is where the throne of God exists. So that proves your point right there. I mean, it's in Scripture. It's all over Scripture. So I think that's great.
Well, I typically don't look to Scripture to prove any of the points that we're making. I'm glad if you find that there's some resonance with ideas and writings that you find profound and interesting. But where I look for evidence, where scientists look for evidence, is not in Scripture, but rather in observational evidence that we can find using our powerful telescopes, in experimental evidence that we can find using our powerful accelerators. And that's where we find convincing evidence.
Okay, thank you.
Okay, very good. Next up, we go to St. Louis. Hey, Jack, welcome to the show.
Hi.
Hey, Jack.
Hi, George.
Hi.
Hi. Well, first I wanted to say when I got my job here in St. Louis, the first thing that popped in my head was you and Coast to Coast AM.
I love it. You know, I get back there as often as I can.
Oh, it's a great city. It's a great city. But what I wanted to get was your and Brian's take on my intuitive notion of how our consciousness interacts with our universe. I like to think of our consciousness as a pick-your-own-adventure book. Based on what your intentions are, you phase into the universe that's in resonance with your intentions. I think it could explain the incredible power that our intentions seem to have in our world. I feel that the entire point of our existence is to just have experiences. And, I could think of no more efficient way for everyone's soul to experience exactly what they need or want to experience if you could just phase in and out of different parallel universes. Again, I've just really noticed how powerful intentions are in life. They seem to really be able to literally change your reality. And I just wanted to get your and Brian's take on that idea. Thank you.
All right. Well,
it's an interesting idea, but the one thing that I would stress is when we're studying the laws of physics, we typically apply it to a small number of particles. That's where our mathematics is tractable, where we can actually undertake the calculations. We are unable to describe anything as complicated as the brain, which I think is the seat of consciousness, with any kind of mathematical detail or mathematical rigor. So at the moment, physics really doesn't have much to say about the nature of consciousness, the origin of consciousness, or the mechanism of consciousness. I hope one day that will change. I hope one day we'll be able to give the underlying physical processes that we experience as consciousness. But anybody today who says that quantum mechanics or quantum physics or the laws of physics, that they've understood how those laws give rise to the experience of consciousness, they are not being truthful. We can't do that. And it's totally irresponsible when anybody, physicist or not, claims that we can bridge the gap between our fundamental understanding of the laws of physics and the experience of consciousness. I wish we could do it. We can't do it yet.
Brian, what's next for you, by the way? Any research projects out there?
Well, I am working, in fact, very hard on a number of the ideas that I discuss in the book, in The Hidden Reality. In fact, in the middle of the book, I describe the possibility of how, according to string theory, our universe can undergo very interesting transmutations, where the extra dimensions, this is one of the features of string theory, the extra dimensional shape of our universe can undergo a dramatic change via the processes of quantum mechanics. So that is where my research focus is at the moment, and I hope one day through these kinds of mathematical undertakings to be able to help the field make some quantitative predictions about what we should be able to see, what we should be able to measure if indeed some of these multiverse proposals are correct. Again, I find the ideas exciting, I find them compelling, but it's only when they can make predictions that are testable that we'll know that they're real. And I'm working hard together with many other physicists around the world to help to realize that eventuality. And that's really where my research focus is.
Jeff is in Goldsburg, North Carolina. Hi, Jeff.
Hi, George. Hi, Brian. As a shareholder of the Green Bay Packers, I'd just like to say congratulations to the team for their big Super Bowl. Had to get that in.
You made billions on that one.
Anyway, I'm an atheist listener here in North Carolina, and theists like to use what they call the fine-tuning argument as an argument for the existence of God. And, Brian, I just got your book in the mail the other day. I was wondering if you touch on that in your book and can you refute it by using, for example, the cosmic string landscape, multiverse, where there's 10 to the 500th number of universes generated by changing Calabi-Yau manifolds?
Yeah, it's a great question, and maybe I'll just spend 30 seconds on a little bit of background. We have learned over the past 100 years or so that there are some particular numbers that describe our universe that are vital for our universe having the features that it does. These are numbers like the mass of the electron, the strength of gravity, the strength of the electromagnetic force, a list of about 20 numbers that we've measured to incredible precision. And the remarkable thing that the caller is indicating is that if those numbers had even slightly different values, the universe as we know it and experience it wouldn't exist. The reason is, for instance, stars rely upon nuclear processes to generate heat and light. If the numbers that I'm referring to had different values, nuclear processes wouldn't happen, stars wouldn't light up, and without stars there wouldn't be life and planets and everything that we know and love about our universe. So the question is, why do those numbers have exactly the values that do allow stars to shine, that do allow planets to form, and on at least one such planet they do allow life and, in fact, intelligent life to evolve? Now, some people say, well, that's evidence of God. It must be that there's some divine being that set all of those 20 numbers at just the right values to allow us to exist. Others suggest that there may be more scientific explanations, and the multiverse, as the caller is indicating, does offer that possibility. If there are many, many, many universes where these numbers can vary from one universe to another, then the mystery of the fine-tuning pretty much goes away. There wouldn't be any particular fine-tuning. It would just be that all of the possible numbers are realized in different universes, and of course we happen to live in that universe where the values are compatible with stars and planets and life, because we are life, and we need a planet, and we need stars, and therefore we need to have the values that our particular universe has. But there's nothing special fundamentally about the numbers that we witness, because other numbers are realized in other universes, and that would be the end of the story. So yes, the multiverse does give us an alternate explanation to the fine-tuning argument.
Great, super.
And yes, and I do talk about this in the book, in The Hidden Reality. This is one of the drivers for the conversation. It's one of the drivers for thinking about the power that a multiverse proposal gives you.
Do physicists get together every once in a while and discuss all these things in mass?
Well, we definitely have our conferences. We have, for instance, an annual string theory conference. This year it's going to be held in Sweden sometime, I believe it's in June or July, and I'll be out there. And we do get together in smaller groups as well. It's a very collaborative subject. There are only a few physicists who spend most of their working days in isolation in their office by themselves. Most of us work in groups. I have a group of postdocs at Columbia that I work with. I have students that I work with. I've got faculty at other universities that I work with from time to time. So in that sense, it really is an endeavor that's communal. It's not really just the isolated genius that we often think about when we think about a scientist. It's really a lot of people who are interested in the same problem getting together and working hard on it.
Becky is in Schenectady, New York, east of the Rockies. Hey, good morning, Becky.
Good morning, George. It's a great honor to speak with you again.
Thank you.
And good morning, Brian. Happy Valentine's Day and love to the world. Brian, I have a question for you. I've been a performing poet for 35 years, and I've often heard through the years that poetry is a lot like mathematics, and mathematics is a lot like poetry. And I was wondering, if you read poetry, I've understood quite a bit about everything you're talking about tonight, although I've had no formal education in mathematics or physics. And I was just curious as to whether you read poetry.
You know, I can't say that I read it on a regular basis. It's not like I have a favorite poet or a favorite poem. I've enjoyed the poetry that I've encountered from time to time, and I think the connections that you are referring to are real in the following sense. What is physics? What is mathematics? Well, it's all about finding patterns, patterns in data, patterns in observations, patterns that we can then encapsulate in mathematical statements. That's what math is. It's a way of formalizing the idea of a pattern. You know, when we say 2, 4, 6, 8, 10, that's a pattern. When we say 3, 6, 9, 12, that's another pattern. And math is very good at encapsulating those kinds of patterns. What is poetry? Well, poetry is finding patterns in words, patterns in the rhythm of words, patterns in the sounds of words, patterns in the meaning of words in order to communicate an idea. That's also what music is. Music is another way of encoding patterns. That's patterns in sounds that are produced by a musical instrument. So I think all of these approaches ultimately are about pattern recognition, about formalizing and framing new and unusual, unexpected patterns. In that sense, there is a resonance between all of these approaches to describing and thinking about the nature of reality.
All right.
Thank you.
Thanks, Becky. Appreciate you being part of the program. Carl's in Milwaukee, Wisconsin. Go ahead, Carl.
Good morning, guys.
Morning.
Brian, gosh, you're on fire tonight. I'm one of those guys. I truly love science, and I wanted to thank the Coast to Coast team for doing the impossible, meaning you're both entertaining and enriching. And I've got such an eclectic library over the years, George, from Hancock to Monroe. And, Brian, I can hardly wait to go and get Hidden Reality.
Well, thank you.
The question that I have, just from listening, that it seems to me that an idea for or theory, that first you have to have that wonderful, fertile imagination, and then comes out, you sharpen your pencil with a math. Does that seem to be kind of the order of things? First you have that idea, and out comes the math to prove it?
Well, it's a great question, and the answer partly depends on which scientist you're talking to. There are some scientists who do work in the mold that you're talking about. They look at the world, they look at data, they come up with some theoretical idea, and then they try to formalize it in mathematical equations to see whether or not it holds water. There are other physicists, though, who work in the opposite direction. They are driven by the mathematics. They are constantly calculating, constantly looking at various equations, and from the mathematics, they try to extract some overarching theoretical idea. Einstein himself is a very good example. In his early days, Einstein was more in the former description that you gave. He was doing thought experiments. He was thinking about motion. He was thinking about how light moves, and ultimately came up with ideas that he then ensconced in mathematical formulae. Later in his life, however, he kind of flipped things around. He was searching for the unified theory, and it was pushing totally with mathematics. And many of us think that he kind of got lost in the mathematics, and that's why he never came upon the unified theory. He was being driven less by the overarching theory and driven more by the mathematical equations. He was more successful when he was driven more by the ideas and less by the math.
How many other dimensions do you think might be out there, Brian?
Well, if you believe string theory, then there would be a total of 11 dimensions. 10 of those would be spatial. One of them would be time. And we only see 3 of those spatial dimensions in the world around us. We all know about left, right, back, forth, up, down. Those are the 3 dimensions that you and I move through freely in our day-to-day lives. But according to string theory, there would be more spatial dimensions. And the puzzle is, why don't we see them? And one explanation is that the other dimensions are crumpled up into a very small shape. The extra dimensions are all around us. They're just too small for our eyes to see, too small for even our powerful equipment to access. And what I discuss in the Hidden Reality is there are many candidate shapes for those extra dimensions, and each shape gives rise to a different kind of physics. So one multiverse that comes out of string theory suggests that there are many, many universes, each with a different shape for the extra dimensions. And this is what ties into what one of the earlier callers was suggesting, which is that maybe rather than having this fine-tuning argument suggesting a divine intervention, it may simply be that there are many universes with many different shapes for the extra dimensions, giving rise to many different physical features, and we live in that universe that's compatible with the physics that is required for the human body to exist. And that would be the end of that mystery.
Stay with us. We're going to come right back with final phone calls with Brian Green in just a moment on Coast to Coast AM. Well, on our next Coast to Coast program, Marianne Winkowski, the ghost hunter, joins us as she talks about why do ghosts simply hang around, followed by those special Friday night and the Saturday morning open lines. Brian, earlier we were talking about the 9 variations of the multiverse. I don't know if we covered all of them or not. Did you want to put a couple more out there for us?
Well, in
the hidden reality, I discuss a couple at the end that are of a somewhat different character than the ones that we've discussed. For instance, I discuss in somewhat more of a light fashion, almost a fanciful light relief to end the book, the possibility that we may be in a computer simulation. So this is familiar to anybody who's watched The Matrix.
Or a dream.
Or a dream in a sense, but one that would be dictated by rules that could be codified in a computer program. You know, in The Matrix, we saw this happen in a very fanciful and compelling storyline for people who like that film. But, you know, it's interesting. I don't introduce this idea in the book in order to get people to take it as a serious possibility for the nature of reality. But it does allow us to gain insight into an interesting question that people have asked for a long time, which is this. Is mathematics, and we've discussed a lot of math tonight, even though the book is purely non-mathematical, it is based upon mathematical investigations. Is math a description of reality, or might math actually be reality? And it's often hard for people to get a sense of what one would mean by math being reality. But if we are in a computer simulation, I think it gives you an intuition for what I'm talking about. Because let's imagine that you and I right now are actually in a computer simulation.
All right.
It feels real, right? I mean, this certainly feels like it's reality. But if we are in a computer simulation and someone were to open up that computer, what would they see inside? Well, they'd see ones and zeros dancing this way and that, guided by mathematical equations. So if we are in a simulation, this would be what mathematics feels like. We would be nothing but ones and zeros dancing inside of a computer guided by mathematical equations. So that gives you some sense of what it would mean for math to be reality. So it's a nice example. It's a nice way of thinking about how that notion would play out if indeed math is real, not just a description of what's real.
All right, let's go back to final calls in Destin, Florida. Dave's with us. Hey, David, go ahead.
Good morning, George.
Good to have you with us.
Dr. Green, good morning.
Good morning.
I have an East meets West kind of odd question. I always hear about this Lotus Sutra, and there's a concept in there. The highest concept is cause and effect are simultaneous, not one before the other, whatever. And when I hear about this spooky action at a distance and I study it, I think, and I'm wondering if you might think or in the future might take a look at in your research, if this guy in India over 2,500 years ago sitting under a tree was actually talking about spooky action at a distance, and that was his Lotus Sutra, holy grail, teaching of all teaching. You know what I mean? If this is something that we can unlock the keys to the universe literally here with this. You know, I just read Biocentrism by Dr. Lanza, and I promise you I'll order your book. Sir, I have respect for you, and thank
well, I appreciate that, but let me just jump into that because it is a question that I think many people have, and they frame it in various ways, which is it possible that some ancient knowledge that is encoded, say, in ancient Hindu texts or Buddhist texts or any other of the scriptures that people have passed down through the ages, might that contain some of the truths that we are discovering in modern science? May we only be rediscovering things that were known in some intuitive way long time ago? And I think the answer is no. I mean, I do find that there are often interesting parallels in language, resonances of ways of describing things in ancient texts and some of the more modern perspectives. But I think that's all that it is. It's just a resonance of the description. There's no way that anybody 2,000, 2,500 years ago could have, for instance, predicted what quantum mechanics predicts. Quantum mechanics allows us to predict the magnetic properties of electrons to 10 decimal places. To 10 decimal places. We do the calculation, we compare it to observation, and they agree to 1 part in 10 billion. That kind of precision, that kind of very specific prediction simply doesn't emerge from any of the ancient texts. So even though there might be some resonance and similarity of description, I don't think it goes beyond that.
Okay, very good. Next up, let's go west of the Rockies. Alex in Phoenix. Go, Alex.
Hi, George. Thanks for having me on.
Sure.
Your guest tonight is very well read, very well spoken and articulate.
He's one of the best.
Yeah, absolutely. So, Brian, I wanted to ask you, given all the different layers of reality, and especially with regards to parallel universes and all the eccentricities that go in therein, particles not being at the same place at the same time, could there even be the concept of an objective reality? And if so, could anyone experience it? And, given the fact that consciousness is, in my opinion, what brings meaning to reality and matter, and as an add-on to that question, do you think that avatars throughout history, such as Jesus or Buddha, might have experienced such a reality?
It's a very tough question. I mean, the second part I'm not sure how to address, but the first part, could there be an objective reality? Well, that's a basic assumption that goes into all of the work that we do in physics. We assume that there is a reality out there. It's a reality that ultimately can be described in mathematical terms, and we do our best to use mathematics and observation and experiment to reveal that objective reality. Now, you can always refute that by saying, look, any observation you make, any experiment you undertake, ultimately is filtered through the human brain, through the human mind, and therefore we can't ever get at anything that's fully out there, fully objective, because it's always filtered through our subjective minds, our subjective brains, our subjective consciousness. And there's no way that I can argue against that. All I can say is the fact that our math does make predictions, and whether that prediction is made by a physicist here in America or one in China or one in Japan, it doesn't matter. We all come to the same conclusions based on the mathematics, and our experiments all reveal the same data. That gives us a sense that there's some objective thing that we are all looking at, even though we necessarily process our observations through our subjective minds, but we can't really prove it. You could take the position, ultimately, that there is no reality. It's all just taking place in this great thing inside our heads, and maybe that's not even real. But once you go down that route, you're down a rabbit hole from which you won't escape. So we definitely don't go there. We assume that there is an objective reality. We assume that our math and our experiments are tapping into it.
Are you in awe with the universe, Brian?
Completely.
Me too.
I mean, the awe is, I think, best described in a way that Einstein again said. He said, look, the most incomprehensible thing about the universe is that it's comprehensible. And that is spectacular. It could have been that there's a universe out there that we could never understand. It would always baffle us. No matter how hard we tried, no matter what experiments we did, no matter what math we developed, it might always elude us. It might always be undescribable in the terms that we have access to. That, so far, is not the case. Our math is able to describe the behavior of tiny particles, a billionth of a meter, in terms of their interactions. Our math is able to describe the nature of black holes that are gargantuan inside. Our math is able to describe the properties of our universe. The math may even be able to describe universes beyond ours. That is spectacular, and it is definitely awe-inspiring.
All right, back to the calls. We'll go to South Bend, Indiana. Tim's with us. Go ahead, Tim.
Hey, George. Hi, Brian. How you doing?
Good.
Hi. Hey, I have this question. When I was a young man, I had this thought in my head, or hypothesis, if you will, that, you were speaking about patterns, and I'd like to see if quantum mechanics has discovered any of the relationships between patterns in people's brains and the relationship of the movement of charged particles from one person's brain to another in terms of a pattern that somebody else can recognize, giving rise to the concept of extrasensory perception or mind reading or things like this. The intuitiveness is one thing, but
certainly no. The answer to that is definitely no. I mean, it's funny. I was on one of these comedy shows, the Colbert Report, about a week or two ago, and the guest before me was talking about evidence for ESP, and he's a real scientist from Cornell, and he has some strange data that he can't explain and claims it's evidence for ESP. And when Colbert asked him, so how do you explain it? He said, well, I don't know. And Colbert pushed him. He said, well, come on. Do you have any ideas? And he said, well, quantum physics is probably the answer, and your next guest, namely me, is the guy who can explain it. And I was cringing backstage because I can't talk about the relationship between quantum mechanics and the brain. No doubt there's some connection, but as I was saying earlier, the brain is too complicated for us to analyze with our rudimentary quantum mechanics mathematics. So however much one might want to use quantum mechanics to describe some strange behavior of consciousness. We just can't do it yet. So there is nobody who is on the level who will be able to draw a link between quantum physics and some of the weird things that one might hope is true, such as ESP or some of the other strange things that have come up in various kinds of experiments, or actually probably imaginations just run wild. Bottom line, consciousness is too complicated for us to describe using the known laws of physics.
Jim is in Wichita Falls, east of the Rockies. Go ahead, Jim. Good morning.
Yes. Thank you, George. It's a pleasure to talk with you. About 10 or 15 years ago, I'm thinking roughly there, I saw it was either a 60 Minutes or a 2020 program where the host was interviewing this individual that's supposed to be like the most intelligent man in the world. He had an immeasurable IQ, and ironically worked as a bouncer in a bar in New Jersey. And during the interview, the host asked him what he was working on his computer, had a computer over in the corner of the room. Yeah. And the guy told him that he was in the process of writing a book which would mathematically prove the existence of God. And so I'm wondering if you or your guest know anything about this individual or ever heard about him or his book or anything?
Yeah, I don't know anything of what you're speaking, and it's a little hard for me to imagine what a mathematical proof of God would be. So sounds curious, but I know nothing about it.
It was a fascinating program. They had these professors from Harvard and everywhere that had tested his IQ, and he refused to work for government think tanks and that sort of thing. But he was just a brilliant, hyper intelligent individual. They said that there was another individual, a man in Russia or somewhere, that was supposed to have a similar IQ level, and they were like just walking geniuses. So I was wondering if you, George, might have heard about that program.
It was it Kirk Dirtson, the author?
I honestly don't recall the name, but I know it was it was either 60 Minutes or 2020 that did a special on him one night, and it was just a fascinating interview,
Well, I guess if you're going to find out, Brian, it's going to be mathematics that does it, huh?
I guess, but again, it's hard for me to see how one would bridge mathematics to these other ideas about ESP or God that are fundamentally non-mathematical, at least in terms of how they're normally framed.
Let's go to Ryan in Washington, stayed up. Hey, Ryan, go ahead.
Hey, how's it going, guys? I'll keep this brief. I got kind of late into the conversation. Yeah, Brian, I was just wondering that have you ever met John Nash? The guy who was on The Beautiful Mind.
No, I don't think I've actually met him personally. Of course, I know who he is, but I don't think I've met him personally.
Okay, yeah, he was pretty intelligent, but he had a disabled the problem that prevented him from functioning. But okay, I was just wondering if you ever met him, ever knew about him. You guys both have a good night.
All right,
thank you.
Played by Russell Crowe, I believe.
Yes, in the movie, absolutely.
Whom I have not met out here yet either. Good actor. Justin in Manhattan, New York. Go ahead, Justin.
Hi, George. Great show. Been listening for many years.
Thank you.
Dr. Green, I've read some of your books, and it's a pleasure to speak to you. My question's a little bit different, but it relates to some of the previous topics. When we deal with an idea, Dr. Green, this is for you. When we deal with an idea like dimensionality, we have to have like an antecedent experience of spatiality before we can map it, like with 3 dimensions or a temporal dimension. So when we're dealing with something like string theory, where we don't have, say, like an empirical experience or like an experience of the spatiality of these things, isn't it kind of, couldn't, talking about like things like ESP and, things like ghosts or mapping God, there might be like mathematical models to undermine these things, but if we don't have like an empirical experience with them, isn't that kind of like a form of fictionalism maybe, or like a, you know what I mean? Like,
sure, I do.
Like sometimes these ideas are not.
Yeah. No, it's a very natural thought, especially when we are, as you're saying, dealing with realms for which we don't have any empirical support and we don't have any antecedent experience because of the fact that we don't have any empirical support. So how do we proceed in a context like that? And it's a great question because it really speaks to the title of my book. In other words, we've been talking about a whole variety of multiverse proposals. So you might say, why didn't I call the book The Hidden Realities, plural? Why did I call it The Hidden Reality? And the reason I call it The Hidden Reality, the singular, speaks to your question. To me, the true underlying singular new idea that science has brought forth is that math is a good guide to figuring out the nature of reality. Math itself can take the place of experience. It can be the guide towards finding the experimental support that ultimately you need to believe any of these ideas. That's the common thread that runs through all of these ideas, from Einstein through quantum mechanics, through string theory, through this possibility of parallel universes. We have to trust the math, see where it takes us, ultimately hoping that it will give us the insight to gain the experimental, the empirical evidence that you were referring to. Ultimately, though, before we get to that empirical evidence, it is the math that we hang on to.
The Hidden Reality, Parallel Universes, Brian Greene. Why'd you call it The Hidden Reality?
Well, there's much about everything that we're talking about that we can't see, that we can't yet experimentally deal with, that we can't use telescopes to observe. In that sense, it is deeply hidden. Nevertheless, it might be real, hence hidden reality.
You got it. Brian, thanks for being on the program.
My pleasure.
Always a pleasure. Brian Greene, The Elegant Universe, The Fabric of the Cosmos, and now his latest work, The Hidden Reality. I remember interviewing him back in 1998, I think, something like that, and he was as gracious then as he is now.